All right. Well, good afternoon, everybody, and hopefully welcome back to the virtual Harmful Algal Bloom Research Symposium. Many of you attended this morning, and those of you who are new, we'll go over just some housekeeping things. This is our fifth year, and we are super excited for your interest and support. This morning's session focused on HAB prediction, prevention, and treatment. While this session we have two great presentations focusing on HAB human dimensions. We will then have a 15-minute break before starting session 3, which focuses on HAB monitoring and detection, and that begins at 1:45 Central Time. My name is Laura Essman, and I am the Managing Director of the Indiana Water Resources Research Center at Purdue University, and I will be your moderator for this afternoon's session. Each session will be facilitated by a member of the Algal Bloom Action Team, which is a collaboration of water professionals, researchers, and educators from 12 states in the North Central region of the United States. Team members include the National Network of Water Resources Research Institutes, the North Central Region Water Network, and University Extension within each state in the North Central region. In addition to hosting this annual symposium, our team has developed a website of resources that can be used freely for outreach and education around harmful algal blooms in the North Central region. And we encourage each of you to visit this website, which I'll be putting in the chat in just a second if Ann doesn't beat me to it. We have resources there that include what you should know, fact sheet, a fact sheet on preventing and treating HABs for landowners, a fact sheet focusing HABs and their health-related effects on animals, and a HABs frequently asked questions database. In addition to this symposium, we also host a bi-monthly webinar series where we feature the latest HAB research all year round. On our website, you can find recordings of these past webinars, information on upcoming webinars, as well as access information and recordings on our past HAB research symposia. Just a few things before we get started. Each presenter is allotted a half an hour, roughly about 20 minutes for the presentation, followed by a 10-minute Q&A. We will allow time for Q&A after each presentation. To have your questions addressed during this time, please post them in the Q&A panel, which can be located at the bottom of your Zoom screen. If there is a question already posted in the Q&A panel and you have the same question, use the Zoom upvote function on a similar question. We will answer the most upvoted questions first during the Q&A. Please note that the Q&A panel function is separate from the chat function. If you have questions for presenters, please post in the Q&A panel. If you have technical difficulties during the symposium, please let us know using the chat function. Also, please note that we will stick to time, so if we have to cut questions off when we reach the end of the allotted time for that presenter, we will. That being said, please put your questions in the Q&A panel, not the chat function, as presenters will try to do their best to answer remaining questions in written form as time allows. As I mentioned, following this afternoon session, we will break for 15 minutes and we'll resume at 1:45 Central Time. All symposium presentations are being recorded and will be posted to the Algal Bloom Action Team website at the conclusion of this event. We will also post the presentation slides to this website for your reference. All right, everybody is here to listen to these wonderful speakers. So our first speaker today is Erica Cleats. Erica is an extension educator for the Michigan Sea Grant with Michigan State University Extension. She works with local communities, agencies, and other partners and networks on initiatives such as habitat restoration and coastal community development. Erica coordinates bi-monthly meetings of partner agencies and organizations who do harmful algal bloom outreach and engagement in Michigan, a group that hosts the HABs 101 and Algae 101 webinars. She also completed research on aligning audience needs with scientists' information in the complex harmful algal bloom outreach to engage continuum. The title of her talk is Harmful Algal Bloom Risk Perception and Community Engagement, and I am going to stop sharing and let her get started.
All right, great. Thank you, Laura. I'm going to get my presentation pulled up here. All right, how's that looking?
Looks great.
Awesome. Well, thanks so much for having me, and I'm happy to talk about our research project today, harmful algal bloom risk perception and community engagement. So this work was done actually mostly prior to my arrival with Michigan Sea Grant and MSU Extension. So Heather Triesenberg, Diane Dobernack, Alex Benitez, as well as Jennifer Hunnell and Martha Gehrig are some of the people that have worked on this project. All right. I just wanted to confirm that MSU is an affirmative action equal opportunity employer and our programs are open to all. In addition, we acknowledge that our campus and statewide offices occupy the ancestral, traditional, and contemporary lands of the Anishinaabe, the Three Fires Confederacy. And we include this land acknowledgement as a way to recognize and support the sovereignty of Michigan's recognized Indian nations. Today, I'm going to be talking about the Great Lakes Center for Freshwater and Human Health, and specifically the community engagement core within that center, which is what the research that I'm talking about today came out of. And then I'm going to finish up with some current programming that we're doing that's come out of this work, as well as future directions. So the Great Lakes Center for Freshwaters and Human Health is a part of the Oceans and Human Health research funded projects. So these projects are found throughout the country. They're in the initial round. There were 6 of these in different areas. Uh, the Freshwater Center, though, was the first one to specifically address freshwater as opposed to saltwater. And that grant began in 2018 and just finished up this year. This work arose out of the Toledo water crisis. So when harmful algal blooms, algal toxins got into the water system of the city of Toledo, shutting down water use for the city for several days in 2014. And that was kind of the origin of a lot more focus in the Great Lakes on the issue of harmful algal blooms. So the Great Lakes Center was made up of 11 algal bloom researchers and 9 universities. It was based at Bowling Green University, and George Bullerjean was the lead for that project. As I mentioned, these projects are located at different places, and the projects are co-funded by the National Science Foundation, as well as other institutes that are part of the National Institute of Health. So they look both at the science of HABs in terms of why are blooms occurring, why are they toxic, what might increase the toxin levels. The grants in this area also looked at things like are toxins being aerosolized? And then they also look at the human health implications of that research. So some of the work through this center was based at University of Toledo, looking at can we develop testing to determine if someone has been exposed to algal toxins, for example, and other projects related to that. So as I said, the community engagement core for this work was based at Michigan State University, and the objectives of that work were to conduct community engaged scholarship training, to evaluate the impacts of any training workshops, to engage in a stakeholder needs assessment for Great Lakes and environmental health literacy, in order to better understand what the outreach information needs were, as well as conducting a vulnerable population needs assessment in order to inform targeted health communication campaign. So the goals did shift a little bit as this grant took place over COVID. So some things, of course, had to adjust, but in general, that's still what was addressed. So one of the earlier projects that happened was the Community Engaged Scholarship Institute, and this was held in May of 2019 with 21 participants. And this included researchers from the center, as well as their postdocs and graduate students. Um, so the idea was to train scientists in how to work more directly with the community. And there's a paper that describes how this workshop was conducted, as well as some of that evaluation data on how effective the training was. Another thing that was developed through this grant was a number of risk assessment maps. So they began with looking just at the Western Lake Erie Basin, which is where the focus is for the Great Lakes Center for Freshwaters and Human Health. It's focused on Western Lake Erie. Um, and then in this analysis, they also looked at Saginaw Bay as well, just to the north. So this analysis was based on looking at underlying health conditions, the adaptive capacity of communities to a bloom or other thing occurring, as well as water quality conditions. And so this is kind of like a screenshot from that dashboard that was created. And then there was also a community health fact sheet created as part of this work. Based on that, they decided to expand the work to be a little bit more broad. So that work was done with the MSU Institute of Water Research and some USGS funding. And so rather than just restricting the analysis to the Western Lake Erie Basin and the Saginaw Bay, it was expanded throughout Michigan's inland lakes. And so you can see on the map here, there's some areas that are blue. Those are less likely to be negatively impacted by blooms, and the red areas are more likely to be negatively impacted. So those are the hot spots. And this analysis was based on socioeconomic and health data through the environmental justice screening tool. It was based on a watershed scale model from USGS, as well as data from EPA's Cyan app that shows weekly cyanobacterial loading. And so the main things that drove whether an area was determined to be a hot spot or not were areas with high cyanobacterial loads, areas with a high percentage of children less than 5 years old because they're more likely to be negatively impacted by blooms. Young children are, areas with a lot of asthma, as well as any areas with nutrient loads from wastewater treatment plants. So as part of this analysis, there was an article that came out about the top 10 risk areas in Michigan. So this is just a screenshot of that article, and I'll put a link in the chat after the talk to a page where you can find links to a bunch of these, but they're all available through MSU Extension on our website. So if you're curious learning any more about how we did that, feel free to check that out. All right. So the work that I was most involved in on this project was going through the data pulled out of interviews done with Great Lakes Center scientists as well as stakeholders. Um, so stakeholders that were interviewed for this project included lake associations, agencies, as well as public health officials. Based on the interviews with scientists associated with the Great Lakes Center, their desire to communicate results of their research to the public was very high, but they find it challenging to prioritize the time to do that among other research priorities, such as publishing papers or attending conferences. Many scientists involved in this work do communicate regularly with particular stakeholders, and usually in a single format. So they might make presentations most of the time, for example, or they might like assist lake associations with understanding research results, things like that. The scientists were interested in collaborating with the community engagement core in order to help them figure out whether the communication products that they were developing were effective, as well as evaluating when they presented events like lab tours and other things, how effective those events were in communicating the messages that they wanted to communicate. For the members of the public, which was mostly Lake Association members who were interviewed, they mostly were interested in having easily understood information that could be disseminated, like in newsletters or on social media. So kind of short snippets that they could share with their groups. And this work is described in more detail in a paper that came out last year, which is open access. In addition, the Community Engagement Corps hosted a joint center annual meeting that included a panel discussion on bridging the gap between research and clinical practice. As I said, that's one of the big focuses of these oceans and human health work is to make sure that there's discussion back and forth between the health sciences and the natural sciences. And so there's a write-up of this panel summary that you can also find on our website that talks a little bit more about some of the needs that were identified during that discussion. Um, in additional work, Alex Benitez, who was a graduate student, a master's student at the time of this work, did work to understand risk perception and health risk communication for HABs. She specifically talked to people who worked or lived in the area of the Western Lake Erie Basin, as well as some inland lakes in southern Michigan, and talked to them about their experiences with HABs. And some of the things she learned were that most people got their information via local news sources, so local newspapers, word of mouth, or social media like Facebook groups. That few people were aware of HABs and its causes, and some were unaware about the health effects, and they had a lot of questions, for example, on whether it was safe to consume fish in an area with HABs present. Vulnerable populations, people that are kind of subject to risk, potential risk to exposure to HABs, also expressed a lack of trust in agencies. And mostly the public, in this case, was learning about HABs effects directly from their experiences or people that they were familiar with. Um, on the right side of the screen here, you can see two fact sheets that Alex created, and one of them, the turquoise one, that's the cognitive fact sheet, and the red one is the emotional fact sheet. And some of her work, which is still in, it's going to be published, still working on getting it published, the different pieces of it, but um, found that people had a higher risk perception for the emotional message fact sheet than the cognitive message. And even things like the colors of the text or the boxes had an impact on the people's risk perception. So I think that's really interesting work and good to keep in mind if you're involved in developing outreach materials related to HABs. Okay, so shifting a bit more into our present work, um, some of the programs that have come out of this, as mentioned in my introduction, last year we did HABs 101 webinar for the public. We had around 100 people, I think a little over 100 attend, and about 500 have watched the recording since then. And we just presented some basic information about HABs. We had a speaker on the significance of algae, that not all algae is bad, for example. We had a presentation on HABs response. So how do you report HABs? And then finally, some information on preventing HABs, either on your property or potentially working with your lake and your neighbors. And we do have a recording on our YouTube page of that available. We also created to accompany that this HABs 101 resources webpage where we compiled some of the most important resources for Michigan in identifying HABs. So we're trying to um, supplement and kind of pull together resources from different government and excuse me, um, from different websites in one place to make it a little bit easier for people to find what they were looking for. And then also, when we had the HABs 101 webinar, we realized that people had additional questions about algae as well. So we developed an Algae 101 webinar, which discussed algal ecology and some of the algae that is not toxic, but can still become a nuisance in certain areas. So that was another thing that we addressed last year. And these webinars are something that we're planning to continue doing in the future. We're also working on developing a toolkit of graphics, social media type graphics related to HABs. So these are some draft ones related to what is and what is not harmful algal bloom. And then finally, hopefully I'm doing okay on time here. I can't see my time. I wanted to talk about a strategic framework for community engagement in the oceans and human health. So this was a project that was developed collaboratively between the community engagement cores of some of those different oceans and human health grants. And the idea is to help people figure out both where they are falling on this outreach to engagement continuum and if that matches the information or the type of relationship that they're trying to have. So, for example, if you're on the outreach end of the continuum, that's in the alert and inform. So that's generally one-way communication. And it's typically used when there's, for example, a beach closure or a lake closure related to a HAB to inform people about that's happening. It's an urgent kind of communication versus all the way on the other side, more to the engagement side. You'll see co-creation and collaboration. And that is really a two-way communication where both community members and scientists are co-developing um, their they're co-developing the information. They're discussing, what types of questions researchers need to answer. They're discussing what types of information the community members would like to have. So there's a lot more of that back and forth communication. And this is also in an open access paper. Um, so to go into a little bit more detail, like I said, something like alert and inform, this more outreach side, um, is generally a one-way flow of information where you're making some kind of time sensitive or urgent communication, and you're trying to convey some information. And as you go farther to the right over here, you get into researchers and partners working together, and eventually sharing equally in goal setting, information sharing, decision making, and other aspects. So there's nothing wrong with being at any location within this outreach to engagement continuum. Any activity is legitimate and one side's not preferable. It's just helpful to understand if your purpose for your communication is matching up to where you're located on that. So being clear about that can help prevent misunderstandings and miscommunications. Um, because if the public, for example, has a different idea of what your relationship is like between scientists or managers and them, that can lead to um, uh, some misunderstandings, eroding public trust, and potentially making future efforts to work together with those groups more difficult. So I would like to acknowledge our funding sources for this work, which included the National Institute of Environmental Health Sciences, National Science Foundation. As I said, this work came out of the Great Lakes Center for Freshwaters and Human Health. We also worked locally with the Michigan Department of Health and Human Services, as well as several parts of MSU Extension. And Sea Grant is also receives funding from NOAA, the National Oceanic and Atmospheric Administration, as well. Finally, I just wanted to note that this center, the Great Lakes Center for Freshwaters and Human Health, was renewed for another 5 years. So the new grant, George Bullerjean retired from Bowling Green University, so the new grant will be based at the University of Michigan. And the co-directors will be Greg Dick at University of Michigan and David Kennedy at the University of Toledo. And this group is expanded from the first and now includes 28 faculty researchers and 11 universities. And they have a website if you want to learn more about that. With that transition, the Community Engagement Corps is transitioning from Michigan State to Ohio Sea Grant. So Chris Winslow and Sarah Geyer, who's the new educator for HABs work, will be the new leads for that Community Engagement Corps going forward. All right. Thank you. And I think our emails are probably several places, but here they are again here. And I guess I'll leave my slides up in case there's any questions related to those.
Sounds good. Thank you, Erica. We have some questions and we have about 5 minutes to answer them, so good timing. The first question we received was, has a test been successfully developed to determine if someone has been exposed to cyanotoxins?
Not to my knowledge. So that is something that they're working on. I believe University of Toledo was working on both potentially like a blood test as well as potentially tissue testing. But my understanding is there's not currently something that's still something they're trying to develop.
Okay, so stay tuned, everybody. Another question. When you run into people that are wary of trusting organizations like this one, do you have a specific strategy to change their minds? That's part of outreach that I have always struggled with.
Yeah, that's a good question. I would say in some of the groups where Alex had done her work in those communities, they've been impacted by HABs for a long time. And not even just HABs, there's some other issues, other like environmental toxins and other issues in that area. So I don't know if we have the answer yet, but so far what we're trying to do is stick to a more local level. So we're working with the watershed councils in those areas that I think are seen that are a bit more trusted in that area than the state agencies are. So we're still working with the state agencies. We're just having the watershed councils be the ones that are kind of more directly being involved in that work. So that's what we're trying anyway. Yeah.
Okay. If the GIS analysis of health data EJ tool is publicly available, could you please share the link?
Yeah, I'll put some links in the chat after this.
Great. And then we have another question regarding the two versions of the fact sheet that you showed. That was one
Mhm.
was emotional, one was cognitive, and I know that a master's student did this, so you might not be able to answer the questions, but um, do you know how that emotional message was determined and why they chose red as a color? And how did they know that that would impact results? Or I guess they didn't. That was the test, but
I believe that red is sort of more associated with risk. Like if you think of the like the stoplight, red green type of thing. So I'm pretty sure that's why red was chosen. Um, the emotional, I'm not exactly sure how she decided to like set up those two different fact sheets, but I know that the emotional one also focused more on kind of a storytelling approach. So it talks about um, some dogs that were that died after being exposed to HABs, and so it focuses on more of like a story-based approach than the cognitive one, which is more just kind of a this is what can happen with HABs. So. I don't know if that fully answers it, but that's what I can tell you.
great. We just had a question come in. People seem to want to blame someone for HABs. What do you tell them?
That's a good question. Yes, I would agree that in general, people are hoping for a quick or easy solution, and usually there's not one. That's a lot of what we're trying to do now through the HABs 101 and the Algae 101 webinars is I would say it's to like add more complexity to people's understanding of those issues. So both that like not all algae is bad. Algae is a natural part of and an important part of the ecosystem. It's not all toxic. Um, Understanding that there is a nutrient budget in a lake and nutrient levels of the lake, is it a oligotrophic or eutrophic lake? All these things impact how natural HABs might be occurring in those areas. So I'd say that's the main thing we're trying to do is over time to kind of broaden people's understanding of HABs and hopefully to see a bigger picture that might help them over time also understand that the solutions are kind of require a bigger picture look at it as well.
Fantastic. And on that note, I think we're ending at perfect timing, so I appreciate that. Thank you, Erica.
No problem.
Okay. I want to introduce our next two speakers and our final session for our final presentation for this session. One of our speakers is Jordan Murray. Jordan is a harmful algal bloom epidemiologist with the University of Wisconsin School of Medicine and Public Health. She's stationed at the Wisconsin Department of Health Services in Madison, where she's entering her third year as the HAB program coordinator. In this role, Jordan leads the state's public health response to harmful algal blooms. And our second presenter is Tristan Faust. Tristan is a registered environmental health specialist and microbiologist for the Eau Claire City County Health Department in Eau Claire, Wisconsin. She graduated from the University of Wisconsin-Eau Claire with an undergraduate degree in environmental public health in 2016. In 2023, she graduated from Morgan State University with a professional science master's degree in environmental sciences with a special focus in water resources. And today they will talk about blue-green algae blooms, a public health issue in Wisconsin's waters. So let me hand things over to you. I think Jordan will be starting.
Yeah,
Looks
thank
great.
you. Thank you. Thank you so much for that introduction. I'm really excited to be here today to talk about harmful algal blooms in Wisconsin and how they present a public health issue with my co-presenter, Tristan Faust. So cyanobacteria, as you may or may not know, they are responsible for the creation of Earth's atmosphere and water bodies as we know them today. So for the most part, we do like them, but we don't like them when they grow and reproduce and become harmful blooms and create health hazards for humans, animals, and the environment. This happens when some species of cyanobacteria produce toxins called cyanotoxins. Here in Wisconsin, the most common toxin that we see is a strain of liver toxin called microcystin LR. Cyanotoxins, like microcystin, can target certain body systems and organs and can cause mild to severe illness in humans and animals. Usually they're categorized into three general types, and we group them based on the effects that they have on human and animal health. So hepatotoxins like microcystin are our liver toxins. Neurotoxins can have harmful effects on the nervous system, and dermatotoxins can affect the skin barrier. Exposure to cyanotoxins and their resulting illnesses can happen in a few different ways. As you can imagine, ingesting or swallowing water is the most common exposure route, especially for children. If you swallow water with toxins in it, you might not be feeling so good a few hours later. You might experience some nausea, abdominal cramping, and then in worst case scenarios, diarrhea and vomiting. Ingestion of neurotoxins can cause symptoms like numb lips, tingling fingers and toes, and dizziness. I will say that these neurotoxic effects are not very common in Wisconsin. They're usually more common from exposure to toxins in marine waters. But when we do see them in Wisconsin, it's usually in animals like dogs. Eating fish caught during a harmful algal bloom is another possible exposure route. The health effects from this exposure route are not super well known. Based on the research that does exist, it's thought that the short-term risk from eating fish caught during a bloom is generally pretty low, but we still don't know much about the effects from chronic low dose exposure. Another thing that we do know is that there have been no known reports of illness from eating fish caught during a bloom here in Wisconsin. And we know that cyanotoxins are more likely to build up in the internal organs like the liver or kidney rather than the fillet or muscle of the fish. Based on this information, we usually advise people to avoid consuming the internal organs of a fish if they know that it was caught during a bloom. We've compiled this information and data along with health guidance in a new fact sheet that was published. So if you have questions about this topic or if you're interested in getting
a copy of it, please reach out. Otherwise, I think my colleague Gina is going to drop the link in the chat. And inhalation is another exposure route. So when people breathe in water droplets that contain cyanotoxins, they might experience symptoms similar to the cold or flu or allergies, like itchy eyes, runny nose, sore throat, cough. Inhalation is a little harder to study, so we don't fully understand its impact. We don't know exactly how significant this exposure route is, how frequently it affects people, and who is most susceptible to exposure and sickness. The last exposure route I want to mention is dermal exposure. So if a person comes into contact with algal scum or mats, they might develop a rash, hives, or skin blisters. Up until pretty recently, it was believed that toxins are not absorbed through the skin and into the body so they wouldn't cause symptoms beyond skin irritation. However, new research from the University of Toledo um, is showing that microcystin can potentially penetrate the skin and enter the body to impact internal organs. And people with pre-existing health conditions like dermatitis or kidney disease might experience worsened symptoms compared to an in general healthy population. So people will often report rashes that they think are HAB related to the state. We can usually tell right away, or we discover later through thorough investigations and water testing, that the rash they experienced is usually attributed to a different cause, like poison oak or swimmer's itch. And I do want to note that we don't have many documented cases of cyanotoxin related rashes, which makes them pretty hard to classify from a medical and a public health standpoint. Moving on to animals, sadly, our animals are affected by cyanotoxins too. We've seen adverse health effects and even death in dogs, cats, wildlife, and livestock who are exposed to toxins. Symptoms can range from diarrhea and vomiting to lethargy, seizures, liver failure, and death. Toxins are pretty fast-acting agents, so the onset of symptoms in animals and humans as well generally occurs within minutes to hours following exposure. And through our work with veterinarians, we've come to learn that other illnesses share similar symptoms as cyanotoxin poisoning and might initially be mistaken as a HAB-related illness, making them hard to diagnose and treat. These include illnesses like water intoxication, heat-related stress, pesticide exposure, and exposure to other poisonous substances. Here in Wisconsin, several state agencies, we work together to manage and address bloom issues and related illnesses. Wisconsin does not have a standardized statewide monitoring program for HABs. Because there are over 15,000 lakes, the state simply just does not have the capacity to test and monitor every body of water. But to understand where and when blooms are occurring and the overall prevalence of them in Wisconsin's water bodies, the Wisconsin Department of Natural Resources collects bloom reports and analyzes them. And during the recreational swim season, local health departments who have established monitoring programs in the state can report blooms and E. coli and health advisories and beach closures for them to our state's beach advisory database. In 2024, the DNR documented 253 bloom reports, which was 45% more than last year. Of these reports, 75% were confirmed cyanobacterial blooms. Switching gears to the health side of things, the harmful algal bloom program at the Wisconsin Department of Health, also a close partner to the DNR, exists to study HAB-related illnesses and address them at the state level. Since 2008, we have worked to prevent and manage HAB-related illnesses through surveillance of illnesses, outreach efforts, and epidemiological research. Now, Wisconsin is one of the few states where cyanobacteria and cyanotoxin poisoning is a reportable condition. This means that anyone who is aware of a suspected human case of illness related to HABs is required by state law to report it to public health. The DHS receives most of our HAB-related illness reports through our online reporting tool and from our partners at the Wisconsin Poison Center. Wisconsin is a home rule state, so our local health departments have the authority to implement actions to prevent and manage harmful algal bloom illnesses. The Wisconsin DHS works very closely with our local health partners to do this and to conduct illness investigations. Our investigation process usually begins by administering illness questionnaires to the health complainant or animal owner who submits an illness report. We'll ask them a series of in-depth questions about the nature of exposure, symptoms, and health history. Our goal is to figure out if the illness in question could be from exposure to cyanobacteria or cyanotoxins, or if another cause is more likely. And if the illness in question sounds like it could potentially be due to HABs, and if the water conditions are still representative of those at the time of exposure, we will work with the DNR to collect and test water samples. We typically share the water sample results and the health risks with local health officials and provide them guidance and recommendations for what sort of public health action should be taken based on the test results and based on the appearance of the water. So that could be beach closures, health advisories, or administering public notifications like press releases. I do want to note that the state doesn't have standardized recreational guidance for exposure to cyanobacteria or cyanotoxins, so we defer to federal guidance when interpreting our test results. Both the World Health Organization and the EPA have guidance, but we usually defer to EPA's. They recommend that a swimming advisory be posted when cyanotoxin concentrations exceed 8 micrograms per liter for microcystin and 15 micrograms per liter for cylindrospermopsin. And the DHS recommends that local health issue a beach closure when either testing of cyanotoxins or a visual bloom in the water indicates that a significant health risk is present. And so now I'll give an overview of some of the health data that we've collected from our investigations that we've documented across the years. So this is data from 2016 to 2024. On average, our program receives about 25 illness reports each year. This is indicated by the light green bars. It turns out that only a fraction of the health reports we receive are determined to be related to HABs. From 2016 to 2024, only 44% of cases we investigated were classified as HAB-related illnesses. And looking at the distribution of cases in the states, exposure to HABs occurred in lakes and rivers in 27 different counties. About a third of the HAB cases reported exposure to HABs in Dane County, which is actually where I live and where the DHS and DNR are based. Gastrointestinal symptoms, so again, the vomiting, diarrhea, nausea, abdominal cramps, these were the most commonly reported symptoms, which is not a huge surprise. And then musculoskeletal symptoms like muscle pain and aches and cramps were the least reported symptoms. Similar to humans, the signs and symptoms seen most commonly in animals were gastrointestinal, like vomiting, diarrhea. The least reported symptoms were lung and heart issues, as well as abnormal blood levels. And I'll end this presentation with some general statistics from over the years. So 72% of cases were in children under 10 years old. This is actually higher than the national average, which is 50%. Ingestion was the most common exposure route reported in both humans and for animals. Most human and animal exposures occurred at private residences compared to other exposure locations like public beaches, for example. And then 20% of animal cases died. 90% of these deaths were dogs. And I'll just leave you with this. If you want to stay up to date on HAB research, webinar opportunities, and what the HAB program is up to, feel free to email me or to subscribe to our monthly e-newsletter. You can also visit our website for more information. And that is all I have. Thank you so much for your time and attention. I will now hand the microphone off to my co-presenter, Tristan Pels.
Thank you, Jordan. All right, let me share my screen. All right, does that look good for everybody?
It's great.
Okay, thank you. Hi everyone. My name is Tristan, and I work at the Eau Claire City County Health Department in Eau Claire, Wisconsin. And I'm just going to be going over our beach monitoring program that we have here at our local health department. So at a glance here, Eau Claire County population is just over about 100,000. And in the city, we have about 70,000 residents. We're located in the west central portion of the state. All our monitoring then is for inland public beaches. We have 7 locations that we monitor through the summer. And our full routine beach route is about 80 miles round trip. So a lot of windshield time for our interns that help us with monitoring and sampling. So they need a good Spotify playlist or a podcast to listen to on their route. Our goal of our program is to reduce the extent of associated waterborne illnesses by limiting people's usage of the bodies of water during known times of contamination. We have 2 categories then of monitoring. We monitor for bacteria using E. coli as an indicator organism of other harmful bacteria or viruses or parasites that may be in the water. And then we added cyanobacteria about 2017 and have developed then that program since. Um, Using primarily visual observation, we do have a algae torch tool from BBE that does measure the chlorophyll A pigment from cyanobacteria. So we do get 2 values using that torch, and one is from total microalgae present, and then the other value of chlorophyll A is just from cyanobacteria. We visit each of our public beaches at least once a week. Routinely, we will go out on Monday and then we would recheck every day, at least Monday through Friday, if we have elevated conditions. And our monitoring period is from Memorial Day to Labor Day, which is just the peak time of usage from the public. And then we have a combination of guidance that we use to help with the decision of our advisory or closures that we use. And then we're very fortunate to have great partnerships with our city and county parks department for helping us post physical signage at the beach. Um, Most of the time, we see our harmful algal blooms during July and August. Unfortunately, we don't have intern capacity or staff capacity here at the health department to extend that monitoring beyond Labor Day. And so what we do is we take those field measurements out in the field at each location and do a visual observation with a sanitary survey. And then I do have a picture here of each of our signs that we use for harmful algae blooms. We have an advisory sign, and we would post an advisory if conditions look like that a bloom could develop. So maybe we're just seeing sporadic evidence of cyanobacteria, or we have elevated readings on our algae torch. And we give the public then some images of what to look for and educate them that conditions can change very rapidly. So just trying to keep them aware of the risk and what to look for and to definitely stay out of the water if they see those other types of conditions with a bloom. If we go to the beach and we do see a harmful algal bloom with a scum layer covering the swimming area of the beach, we would issue a beach closure. And so we started doing the advisories in 2017, and a closure started in 2022. For public notification, we share our results of our monitoring with the public via our website and social media, Facebook and Twitter, and by email notifications. So we do see a quite of a bit of a large increase in social media following during the summer. The public really seems to look for our guidance, and they take that into consideration when picking a location to swim at. And in addition to our monitoring program, we strive to provide the public with a lot of education and outreach. So we're really trying to educate our residents about what HABs are, how to identify them, and try to stay involved with our local watershed coalition to provide information on our monitoring efforts. And so we've developed just a few outreach materials with the help of materials that Wisconsin Department of Health has put out as well. So we give the flyer on the left, Protect Your Pets. We print these out and give these to our vet offices during the summer. Sometimes it's really helpful to find that trusted messenger. Sometimes people don't always want to take the health department advice. So finding that trusted messenger is really important. And then we also created a coloring sheet for kids, educating them about our beach program. So at outreach events, we'll give kids our coloring pages with some crayons. We have the bottom image here is permanent signage at our beaches to just try and educate the public to not feed the geese and the ducks. Another audience that we try to capture to provide some guidance for is waterfowl hunters. That is something that is popular in Wisconsin. And so in September into October, we will try to push out some messaging and find the best messengers for that information to reach that audience. And then finally, we've kind of just developed also a trifold brochure here on animal safety in regards to HABs. And so that is all I have to go over our program here at the local level.
Thanks, Tristan and Jordan. We have a lot of questions. So, first, I wanted to point out that there were a couple of links posted for the fish consumption fact sheet, and then another one for the beach closings, the Eau Claire County, City County Health Department beach closings, if people are interested in that. Okay, back to the real questions. Are cyanotoxins heat stable or heat label?
Yes, I believe, I'm not sure about all of them, but I know most of them are heat stable, specifically microcystin, so you can't get rid of them just by boiling or through cooking.
Okay, good to note. Okay. Does Wisconsin have a general timeline for how long a beach/water body should be closed by a HAB? Have you collected any data on how long toxins persist once the bloom has subsided?
I can add, Jordan, I'm not sure what you want to add here, but I did forget to mention when we issue an advisory or a closure, obviously our program isn't perfect because we are not performing the toxin testing. We just unfortunately don't have the capacity or funding to do that at this point. So we know that there are flaws with just visual observation, that there could be cyanotoxins present with a bloom and vice versa. So we do keep a 2 day, we don't adjust the signage for at least 2 days after we notice a bloom, so that we're not switching that signage back and forth and just confusing the public with an advisory one day and a closure the next day. So I'm not sure Wisconsin state as a whole, but that is at least our approach to that.
Yeah, and I'm not sure. Well, at the state health department level, we have not collected any data on how long toxins persist once a bloom has subsided, we know that they can persist, but at the State Health Department, we don't have that data. I'm sure someone else has that data. Someone else has done that research, whether that's in Wisconsin or one of the other surrounding states. So if someone does have that information and can report that back out, I'd be interested in knowing that as well.
Another question that's very related, and Tristan already mentioned that you're not using, or your criteria for closure is visual. But the question is, what is the criteria that sets off a closure? So I was wondering from the greater Wisconsin perspective, is there more criteria than just visual?
For us, since we're not doing any of the toxin testing, it is just visual. Whenever we have a bloom with a scum layer covering the swimming area of the beach, that is when we would close. We just really don't want the public, especially children, going into that water when those conditions are present.
I'd say that's the case for a lot of local health departments throughout Wisconsin. Just lack of funding, lack of capacity prevents them from being able to actually test the toxins. And here at the to know the level of health risk present here at the state level, we only test toxins in the water if there's um, health an illness event that happened. So that would set off the toxin testing protocol. So other than that, we don't generally test toxins throughout the water. So usually visual assessment is enough to warrant beach closure.
Okay. There is a question from Rob, and maybe Rob wants to elaborate a little bit, but he asks, what were the limits you use for toxin levels? I know you mentioned using EPA levels. Um, were, are there any others?
Um, yeah, no, yeah, we usually defer to the EPA guidance levels. We don't, which are for the microcystin and cylindrosperm mops, and we don't see cylindrosperm mops in a lot in Wisconsin's waters. It's mostly microcystin. So if anything that exceeds that 8 micrograms per liter is deemed as a pertinent health risk and would warrant a beach closure.
Okay. There was another question that came up during your talk, Jordan, when you were talking about the exposure routes. Is there a limit to exposure time needed to result in any of the adverse effects that can occur? Minutes, hours, seconds?
Yeah, that's a good question. It depends on the exposure routes, but even a few minutes of exposure can result in an illness. That rash photo I showed earlier, that person's foot was in harmful algal bloom water for I think about 5 or so minutes. Um, and even that short time of exposure, a few hours later, it resulted in a rash like that, which as you saw was pretty severe. So it can only take a few minutes um, for an illness to happen.
Okay. How effectively are public health officials able to discern between HAB-related causes of symptoms and other causes?
It's tough. It's tough, and that's why we do our very thorough investigations here at the state level and help our local health partners conduct those investigations. That questionnaire I showed, it's like a 12-page document. We're asking all sorts of questions about health history, specific times of exposure, specific times of onset of illness, how many days the person was sick, do you have any underlying health conditions, were you exposed to any other environmental irritants that you know of, did you eat something weird? So we have to ask those specific questions um, in order to rule out cytotoxins as being a cause of that illness. And with that, that's why we do thorough assessments of the water as well at the exposure site. So if we know that there is a bloom present and the symptoms onset time and the symptoms align with cytotoxin poisoning, then we can kind of get the idea that this illness might be related. So more often than not, it's ruling out ruling out other illnesses and kind of defaulting to a cyanotoxin illness. But it's challenging, I will say that.
Great. Okay. Tristan, you may have already answered this, but I'm going to ask it anyway. You talked about the algae torch results, and this person wanted to know, do you conduct additional lab testing for cyanotoxins when the algae torch results are high, or are you making closure decisions solely based on the chlorophyll A measurements?
Yeah, so with the closure, we're just using that, bloom with a scum definition, and visual observation. With an advisory, usually when the chlorophyll A from cyanobacteria levels get to 12 micrograms per liter, that came out of some updated guidance from World Health Organization, I believe in 2021. Um, is a threshold that we do use. Usually that does coincide with seeing visual cyanobacteria in the water, just not a full bloom yet or a scum layer. But that is when we would at least issue just an advisory to keep people aware that conditions can change rapidly.
Okay, one last quick question because we're 1 minute over. One of the slides showed a bottle of green goo being held in a bare hand. When do you feel gloves are warranted?
Yes, gloves are always warranted. Always wear gloves when you're collecting samples. I usually show a slide right after that, the same picture with the red X.
Yes.
The hand showing that that was wrong. Don't do that because that's how you get a rash. So
Yep.
always wear gloves if you're sampling the water.
Okay, well, I want to thank both of you for a great presentation and our audience for super questions. And thank you. This is concluding a very short but great session on harmful algal bloom human dimensions. We're going to take a 15-minute break and be back for our final session on monitoring and detection that will begin at 1:45 p.m. Central Time. Here are our speaker emails if you want to contact them. Thanks, everybody.
All right. Good afternoon, everyone. It is 2:45, so we're going to go ahead and get started again. Give me 1 second. Let me get on my screens set up here. And are you still seeing my slides?
Yes, they are not in presentation mode.
Okay, hold on. Try this again. Okay. Welcome back to session 3 of the Harmful Algal Bloom Research Symposium. This session will focus on HAB monitoring and detection. We have 5 great presentations for you, and we will have 3 presentations followed by a 15-minute break starting at 3:15 Central Time. My name is Erica Kleitz, and I'm an extension educator with Michigan Sea Grant. I'll be your moderator for this afternoon's session. Each session will be facilitated by a member of the Algal Bloom Action Team, a collaboration of water professionals, researchers, and educators from 12 states in the North Central region of the United States. Team members include the National Network of Water Resources Research Institutes, the North Central Region Water Network, and University Extension within each state in the North Central region. In addition to hosting this annual symposium, our team has developed a website of resources that can be used freely for outreach and education around harmful algal blooms in the North Central region. I encourage each of you to visit our website, northcentralwater.org/HABs, which we are putting in the chat now. There you can explore some of the resources we have to date, including a What You Should Know fact sheet, a fact sheet on preventing and treating HABs for landowners, a fact sheet focusing on HABs and their health-related effects on animals, and a HABs frequently asked questions database. In addition to this symposium, we also host a bi-monthly webinar series where we feature the latest HAB research all year round. On our website, you can find recordings of all of our past webinars, information on upcoming webinars, as well as access information and recordings on our past HAB research symposiums. Before we get started, just a few housekeeping items. Each presenter is allotted a half an hour, roughly 20 minutes for the presentation, followed by 10 minutes for Q&A. We will allow time for Q&A after each presentation. To have your questions addressed during this time, please post them in the Q&A panel, which can be located at the bottom of your Zoom screen. If there is a question already posted to the Q&A panel and you have the same question, use the Zoom upvote function on the similar question. We will answer the most upvoted questions first during the Q&A. Please note the Q&A panel function is separate from the chat function in Zoom. Again, questions for the presenter should be posted to the Q&A panel. If you're having any technical difficulties during the symposium, please let us know via Zoom's chat function, and we'll be happy to assist you as best we can. You can also use the chat function to introduce yourself or discuss the research findings with fellow water professionals at the symposium today. Please note, we will stick to time so that we will have to cut off questions when we reach the end of the allotted time for each presenter. That said, please put your questions in the Q&A panel, as presenters will try their best to answer remaining questions in the written form as time allows. All symposium presentations are being recorded and will be posted to the Algal Bloom Action Team website at the conclusion of the event. We will also post the presentation slides to the website for your reference. All right, let's jump in. Our first speaker is Sam Blackburn. Sam is a data scientist at University of Wisconsin-Madison, focused on using large-scale data sets to understand the interactions between human development and freshwater ecosystems. He is also interested in scientific communication and data visualization, particularly in using web applications to make research accessible to the public. Sam grew up in Ann Arbor, Michigan, and attended Carleton College for a BA in geology and University of Wisconsin-Madison for a master's in freshwater science. Prior to joining the CFL, he worked as a research scientist at the Wisconsin DNR on a variety of projects, including lakeshore habitat health and the National Aquatic Resource Surveys. I'm going to go ahead and stop sharing. Sam, if you can go ahead and pull your slides up.
Awesome. Is everyone seeing my slides?
Yep, that looks great.
Great. All right. I'll take it away then. So hey folks, nice to be here with all of you. I'm going to be talking about some work that I and some fellow scientists are doing up north in Lake Superior, specifically Western Lake Superior. Before I get started, I just wanted to call out the folks I'm working with on this project. So first we have Kate, who spoke this morning. She's at the Lake Superior National Estuarine Research Reserve. I'm also working with Alan Kaufman at the Wisconsin DNR. Matt Hudson at Northland College, Brenda LaFrancois, who is a part of National Park Service, as well as Hillary Dugan, who's also at the University of Wisconsin Center for Limnology. There we go. All right, so first I'm going to just cover a little bit of background. For folks who were here in the morning session, you'll already have a sense of what's going on with algal blooms on Lake Superior, but in case you weren't, algal bloom, particularly algal bloom reports, have become much more common in Western Lake Superior and the Western Lake Superior region over the past decade. This is a little figure I pulled from the Lake Superior National Estuarine Research Reserve bloom bulletin that they put out every year. And as you can see, the number of public reports has been increasing, as well as verified bloom events have been increasing over the past decade. So this is a somewhat hot button issue up in Lake Superior, and something folks are really interested in learning more about and better understanding. As a result of these blooms becoming more frequent, as well as just routine monitoring, there are lots of people who are already collecting data in the Western Lake Superior region. Among those, the USGS, the US EPA, National Park Service, Wisconsin, Minnesota Departments of Natural Resources, Northland College in Ashland, Wisconsin, as well as the Lake Superior National Estuarine Research Reserve, as well as other tribal organizations as well. So can we learn more and better understand the dynamics and causes of algal blooms in the Western Lake Superior region if we combine the data from all these groups together into one large data set? And hopefully the answer is yes, because that's what my role here in this project is. So first, I just want to talk about what's in this data set because we we have worked really hard to make this open and available to the public. So I'm hoping that some of you on this call will be able to potentially make use of these data in your work. And so I'm going to talk a little bit about what's in it and as well as how to access. So first, just to get a sense of scale of what we're working with here, we were combining over 50 individual data files, as well as pulling information from the National Water Information System, which is USGS, as well as from the Water Equality Portal, which is an EPA resource that works with various agencies to make their data available to the public in an accessible format. So far, we have 14 years of data ranging from 2010 to 2023, with 2024 hopefully being added soon as folks process their data from the field season in 2024. Across the lake and tributaries in the watershed, we have over 40,000 site days of data. So that is one observation on a day at a single site. In addition, we also have almost as many additional days of just discharge or stream flow data from sites from tributaries in the watershed. We also have around 3,000 site days specifically measuring Lake Superior to give you a sense of what is actually available on the lake itself. And here's what that looks like visually. You can see that we have a pretty great spread of sites in the tributaries. Those are the blue sites. We also do have quite a few measurements in the St. Louis River estuary, which is near Duluth. And that's in our red color. And then we also have a good distribution of sites in green, which are lake measurements. Just to orient you as well, I'm not sure if you can see my cursor, but in the lower left, I have a box just showing you where we are in Lake Superior in that western arm. All right. So I have a couple text-heavy slides here that I'm going to move through quickly. These are going to be available as a resource in the slides that come out in case you are interested in using this data set and want a quick reference of what's in it. So moving somewhat quickly through these, we've separated the combined data into 3 different chunks, one being our lake measurements. Those were the green before, another being the estuary measurements, which were in the red before, and finally our tributary measurements. Those were in the blue before. Everything in the data set are surface level observations. We stuck to a less than 2-meter depth for all measurements just to keep things consistent. And we also averaged measures if more were present, more than one were present on a single day, so that everything is a daily average or represents what can be considered the daily average at that site. We have a broad variety of chemical and water quality measures available. Some standard water quality like temperature, dissolved oxygen, pH conductivity, as well as several different nutrients. We have numerous different types of nitrogen measurements, phosphorus measurements, carbon. We have some, for those of you interested in nutrient stoichiometry, not sure how many of you there are out there, but we do have those ratios pre-calculated. And then there are also measures of chlorophyll, of course, which are the focus of the study, as well as some silica, chloride, solids. We try to keep units consistent across the board. And I do want to mention that there are some other less frequently measured attributes available as a part of this data set that I won't be talking about today, but if you're interested, we can go over those. In addition to those main core data sets, which are easily available, you may also be interested in clean versions of those 50 plus data files acquired directly from agency partners measuring in Western Lake Superior. I also have discharge data for the region all put together, as well as meteorological data from several different weather buoys in the area, as well as annual, monthly, weekly averages for those lake estuary tributary files. If you're interested in those. Again, I'm moving really quickly through this because I know it's something that can be looked back on as a reference if you are interested. So quickly, if you are interested in using our data, You can download those core data sets I described directly from GitHub. The link is here, and I can also throw that in the chat after the talk. Or if you're really interested in looking at the step-by-step how this data set was cleaned and synthesized, as well as interested in maybe some of those smaller additional data sets I just mentioned, you can clone the repository on GitHub. This is a little bit more technical for folks who are interested in that, and I'm happy to answer questions about data access after the talk. So I'm going to pause for a quick sec so I can drink some water. All right. So I want to give you a sense of what kind of research can be done on this newly synthesized data set. So I'm going to talk about a couple different trends you can see over time, as well as across the region. So first, I just want to talk about, one of the things we were really curious about initially upon putting together this data set is, do we see this increase in a chlorophyll, measure of phytoplankton and algal growth, which also can represent cyanobacteria growth. We were really curious to see if this was reflected on the whole, or if, just to see if blooms are a sign of rising chlorophyll in the region, or rising productivity, rising algal growth in the region, or if these blooms are more isolated events. And so unfortunately, we can't actually answer that quite yet because we do have relatively limited number of years worth of observations to be able to see over time how things are changing. In the last 6 or 7 years in this just the western arm of Lake Superior, we aren't seeing an increasing trend in chlorophyll. I do just want to quick mention that this is, we're only looking at sites here that had more than 4 years of measurements, which there were 17 sites across the region. This is based on a seasonal Mann-Kendall trend test, if you're interested in the stats. But yeah, so I just want to, say this is really not necessarily a sign, not necessarily a call saying that the increase in blooms is not real, is not happening, but more just a sign that collecting data over time is really important for understanding these blooms. And so hopefully in future years, we'll have a better sense of what direction algal growth in the region is moving. However, in Chequamegon Bay, which is a small region of Lake Superior that I'll point out on a map in a couple slides, we actually do see a small increase. So on a smaller level, as opposed to being across the entire region, there is a significant increase, just a small, around 0.1 microgram per liter per year, which is we're looking at a scale of around 1 to 4 micrograms per liter here to give you a sense of what that looks like. I have the trend on the plot as well. So in some areas we are seeing an increase in chlorophyll, but on the whole, we are not. And then if you're curious particularly about that St. Louis River estuary near Duluth, which is a really interesting region, it's the focus of the National Research Reserve there. Again, we're not seeing a change in chlorophyll and algal growth dynamics over the past 10 years, which is a longer time frame. So this is a more interesting lack of a trend, though it is more limited measurements. I do just want to point out that we are, just because there isn't a trend over 10 years, doesn't mean that there aren't single years where there are a higher measurement. So if you look in 2020 and 2021, you do see on average that chlorophyll measurements were higher. So you do see variability year to year, which can be reflected in the blooms that you can see in the plot of reports over time. So that was these trends over time. Now I want to talk about trends over space. So this is a plot showing different site measurements in 2021. And this is I've assigned each site that was measured frequently in 2021 a specific cluster. And this is based on a simple machine learning algorithm called k-means clustering. And basically it just groups different sites together based on their median values of chlorophyll, nitrate, ammonia, phosphorus, and soluble reactive phosphorus. 2021 was chosen because it has the best distribution and most consistent distribution across the region. When you expand across years, you start to lose certain sites. And so you can lose specificity as a result of that. And then also these specific parameters were chosen because those were the only ones consistently measured across different agencies and groups who were taking measurements. So you can see different parts of the region have been grouped into 4 different clusters, as I mentioned. We see clear differences between offshore sites, this dark purple, nearer shore sites, which are this blue, nearer shore sites that are highly influenced by tributaries, which are these green, and then a few sites that are right at tributary mouths that are highly influenced by what is happening in the tributaries, and those are in yellow. So when we're looking how those different sites and different clusters compare for these different nutrients and chlorophyll, we can see that these purple sites, these offshore sites in 2021 had significantly higher median chlorophyll values, whereas the blue nearshore sites that were less tributary influenced had the lowest, and our higher tributary influence sites were slightly higher. Our offshore sites had lower nitrate overall, whereas the more tributary influence the nearshore site had, the lower the nitrate. Lake Superior has interesting nitrate dynamics because there's a fair amount of atmospheric deposition, that is nitrogen coming from the air into the lake. And so you can see tributaries are not a source of nitrate in Western Lake Superior. You also see, and so the next three, ammonia, phosphorus, and soluble reactive phosphorus, are all highly tributary influence in terms of the nearshore sites, where you have a broader distribution of offshore sites with regard to ammonia, but based on the tributary influence of these nearshore sites, the blue, green, and yellow, where the blue sites, which are the least influenced, have the lowest levels of ammonia, and the greatest influence have the highest. We see that pattern continue with total phosphorus and with soluble reactive phosphorus. So I know that was a lot of information. I'm happy to answer questions about it, but really I want to give you a sense of, because we have this great spatial distribution across the region, we're able to conduct these comparisons and better understand trends across the region. So how can we use this to influence our monitoring practices? How can we use this information to change and better affect our sampling routines to understand the dynamics of algal growth and cyanobacteria growth in the lake? And so one thing that we wanted to understand was if we can capture a wider range of conditions by sampling at more sites, or if we sample fewer sites but on more days. Currently, most of the groups in the region are sampling no more frequently than every 2 weeks. And so this is just a plot of across a bunch of different key variables. Do we see a greater standard deviation of observed values when we're looking at one site? The standard deviation of observations at one site across a single summer of field work, or do we see a greater variability, standard deviation of observations on a single day across the entire region? So the first is measuring temporal variability, the second is measuring spatial variability. As you can see on this plot, the blue temporal variability, the variation across time, is much greater than the variation across space. So the way to understand this is that we're able to see a wider range of conditions by sampling on more days than at more sites. We're seeing that frequency, seeing that variability across time more than we're seeing it across, even measuring across the whole region on one day. So the conclusion of this initial analysis of our data is that more frequent sampling is needed to understand algal blooms in Lake Superior, in part because of that comparison of variability I just showed you, and also because you may have noticed we're not capturing blooms in the chlorophyll values that are included in this data set. So we weren't seeing really high chlorophyll values in 2018, which was the year that blooms were most frequently being reported. So hopefully more frequent sampling will help us help us and others in the region have more data on when blooms are occurring. Another benefit for sampling more often is that because there isn't a lot of connection between when folks are sampling uh, in the tributaries to the lake and when they're sampling on the lake itself, if we have more measurements, it's more likely that those two measurements will align between tributaries and lake, and we can draw connections between um, those discharge events, those flood events that were mentioned this morning by Kate, if you were here. So as a result of this, we've worked with Wisconsin Department of Natural Resources and Northland College, and they're going to focus on more frequent weekly sampling across the year on fewer sites. So the same number of samples across a field season, but better spread out in time as opposed to spread across space. And with that, I'm happy to answer any questions you all have. I'm excited to hear what suggestions you may have for what you'd like to see done with this data. Or we can just sit and, if you don't have any questions, you can watch how chlorophyll, warmth, and stream flow change over time. So you can see on this animated GIF, you can see chlorophyll in green on the lake. You can see degree days, which is a measure of the number of days in a week that were above 10 degrees Celsius. So it's a measure of warming waters, which is important for cyanobacteria growth. And then discharge is in the tributaries to the lake, and that's in blue. So yeah, happy to take any questions.
Great. Thanks a lot, Sam. We do have some questions coming in here. So one question, why do you think the tributary mouth P is so much higher than in other areas?
Yeah, so it's twofold. Is the tributaries, particularly in that Schwamingen Bay area, I realize I've forgotten to mention. Schwamingen Bay is this area that is highly measured in the eastern side of this map. Um, that is the main tributary there is the Bad River. That's a more developed, more agricultural land use part of the region. And so, in particularly those measurements at those tributaries, because both as a combination of land use and higher discharge, you can see a greater influence of what's going on in the land as opposed to some of the other tributary sites where you don't have as much phosphorus loading in those tributaries.
Okay. Some more questions coming in. Are sampling events outside of the regular schedule to document and observe bloom included in the trend analysis?
Yeah, so if they were uh, measured at a site that is already a part of the trend, they were included. However, those were fairly infrequent. So as a part of the trend analysis, those blooms were not included, in part because if it's at a single site, uh, we don't know what the baseline value is, and so that will potentially throw off the trend for that specific year because, even if the bloom is only a small amount higher than the baseline, which it wouldn't be a bloom then. But if you have a high baseline, you can't necessarily you can't understand how that would affect the median or so for that year. So yes and no. I think that's a big part. If for most part, no, the blooms would not be included even when they're sampled because they're often in a space that's not a part of regular sampling. And so that's an additional challenge for understanding trends because you're not able to necessarily measure trends over time. In the estuary, because it's a smaller region, those blooms are more likely to be captured. And I think you would be able to see some of the blooms on those high days where it was getting up near 80 micrograms per liter. That's getting close to a bloom there in the estuary. Hopefully that answered your question.
I believe so. If not, someone can chime in again and
Yeah,
ask
I'm
another
happy to
one.
answer in the chat. Yep.
Yeah, so another question here. Can you provide any evidence from past studies or explain possible causes for the higher nitrate concentrations in offshore waters compared to nearshore waters in Lake Superior? I think you may have touched on this, but
Yes.
maybe re-emphasize.
Yeah. I don't have a paper citation off my head, but it's very well documented that Lake Superior waters are higher in nitrate than tributary waters in the region because of that atmospheric deposition. That's a pretty well established phenomenon of Lake Superior just because of its size, that you get a lot of nitrogen coming in to the lake itself and not from land uh, non-point source.
Okay, great. And then there's a question about the sampling frequency proposed. I'm assuming that's for the new sampling you mentioned for 2025.
Mhm.
Can you say anything more about that?
It's going to be weekly on a fairly even spread of sites. We worked hard to determine what sites would give the best, most even distribution across the region. It's going to, I think, the typically runs sometime from June when the lake gets warm enough to September or October. Depending on if on climate on not climate on weather conditions. But yeah, it's going to be every week at I think 7 sites or 8 sites from the DNR and um, 5 or 6 at Northland College near Trommingen Bay.
Okay, great. There's a request to post the link to your work in the chat. So just
Yep.
after when maybe one of your co-authors can do that. And then there's also a question about whether the data set includes the EPA Glenpoe spring and summer survey data. Um, so I don't know if that's something you're familiar with off the top of your head, but there's a link you can check out if you're not sure.
Yeah, I will have to check that out. I will say if the person asking a question knows that it is on the water quality portal, then yes, it was included. Um,
Okay.
Otherwise, I would have to double check, but I would be skeptical that it would be included if it wasn't on the water quality portal. But I would love to
Okay.
include it if it's not.
All right. Great. Trying to check over here too. All right. Right. I think that was a question to someone else. Finally, someone says, I'd be curious to also see TSS as part of the TRIB, nearshore and offshore comparisons. I wonder if TSS in the nearshore might dampen productivity at times.
Yes, it's so I also would love to see that. It was missing from around half of those sites that we were looking at in the cluster analysis, and so I wasn't able to include it, unfortunately. But there have been several papers that have documented really clearly that during big discharge events where you have these plumes of sediment coming into Lake Superior, you don't see a corresponding increase in productivity because of the light attenuation that the TSS is causing. So it definitely limits productivity despite providing a lot of nutrients.
All right. Awesome. Well, we'll leave it there. We got to go on to our next talk, but thanks a lot. And yeah, you can check out the Q&A box for anything else you want to add there. Get my screen up again here. All right. Our next speaker, excuse me, is Peter Birchbach. Peter Birchbach is an aquatic ecology uh, researcher at University of Minnesota's Natural Resources Research Institute and current master student in the University of Minnesota Duluth's Water Resources Science program. Peter's work specializes in spatio-temporal dynamics of phytoplankton and aquatic systems and the interactions between phytoplankton and environmental conditions. When he's not collecting samples or at the microscope, Peter enjoys connecting with the natural world in other ways, such as surfing the waves of Lake Superior, catching and cooking fish, monitoring shorebirds, climbing rocks, and capturing photos of subjects ranging from microscopic organisms to landscapes. And Peter will be talking today about informing a St. Louis River estuary long-term monitoring strategy in response to recent unprecedented cyano-HABs.
All right, thank you for the introduction. I will share my slides here.
All right, that looks great.
And are you seeing presenter view right now or just the slides?
Nope, it's just the slides.
Excellent. All right. Well, yes, thank you for the introduction. I'm Peter Birschbach, wrapping up my master's degree at the University of Minnesota Duluth in the Water Resources Science program. And I'm here today on behalf of a collaborative team from the Natural Resources Research Institute, as well as the Lake Superior National Estuarine Research Reserve, to talk about recent cyanobacteria harmful algal blooms in the St. Louis River estuary in our efforts to develop a monitoring program in response. Before I dive into my talk, I would like to right away thank our funders for this project, the Reserve System Science Collaborative, who funded this work that we're doing. So first, I'd like to just familiarize everybody with the St. Louis River estuary, although I won't need to do much of that after the previous talk. Nice to see work in the same areas right after one another here. So the estuary is located in the Duluth Superior area, right between those two cities. It's located at the site of the inflow of the St. Louis River, which is the largest U.S. tributary of Lake Superior. The estuary is a very important resource. Ecologically, it's very biodiverse with a gradient of conditions as you move down the estuary, kind of moving from a more naturalized riverine upper portion of the estuary to a more urbanized lacustrine lower portion of the estuary. Culturally, very important resource, especially for the Anishinaabe people. Is also a valuable recreation resource for the many tourists we get here. In the summer, it's the site of a national water trail for paddlers, and it's also a very important economic resource as one of the largest inland ports in North America. The estuary saw over a century of legacy impairments from all sorts of things, ranging from historic timber practices to industrial pollution discharge to raw sewage discharge in the estuary for decades. However, it has seen decades of remediation progress under the Great Lakes Area of Concern framework. So moving in a positive direction and hopefully approaching delisting fairly imminently. However, there's a new stressor looming on the horizon in the estuary, that being harmful algal blooms. So before I dive into an overview of the past blooms we've seen so far in the estuary, I just want to remind everyone these blooms, we call them harmful because they can produce cyanotoxins, which can be harmful or toxic to the livers, nervous systems, and or skin of people and their pets. So we saw our first ever documented toxic cyanobacteria bloom on the estuary in 2021. It occurred marked on the map here. There's a little green skull on the map. That's the location of Barker's Island, which is also the location of a public swim beach and the reserve's research facility. So at that location in 2021, this bloom occurred. Microcystin was measured at levels above the recommended recreational exposure threshold of 8 micrograms per liter set by the EPA, and saxitoxin was detected at trace levels as well, resulting in a public beach closure. Then 2 years later, in 2023, the first year of our project data collection, we saw numerous benthic and surface blooms throughout the estuary. So in July and August of that year, we saw benthic oscillatoria blooms. This is a filamentous cyanobacteria that was aggregating very densely on the benthos in shallow areas, and then actually detaching and becoming buoyant and aggregating in the water column on calm, sunny days. So we saw that on several occasions throughout the midsummer. Then later in the season, in the early fall, we saw 2 widespread major surface blooms that were, as far as we know, previously unprecedented in spatial extent at the time. And during each of those blooms, we did detect toxins, however, at lower levels than the 2021 bloom, however, still potentially harmful to the public and pets interacting with that water. And then more recently, in 2024, this past season, we saw numerous localized blooms throughout the estuary. We really didn't see the widespread bloom phenomena like we saw in 2023, but we did see numerous localized blooms and once again detected toxins numerous times. So far, all of these toxin detections on this slide occurred at the Barker's Island public swim beach here, but we did have several non-detects during blooms in other locations as well. And so my main point here, these blooms are a recent issue. They're occurring in high use areas, and they're currently fairly poorly understood as to why they're happening. And so after the 2021 bloom, this project was initiated to better understand the factors contributing to these blooms and then develop a long-term monitoring program to detect and respond to them in real time. So now I'm going to go over some of the current monitoring gaps and how our project seeks to fill in some of those gaps. Currently, the dynamics of the environmental conditions and the phytoplankton communities in the estuary remain largely unknown, at least at a large number of sites over a large span of time over the course of a season or over the course of a year. And so one of our basic goals of the project is just to characterize these dynamics and understand a little bit better what's going on out there as far as the community and conditions dynamics and how that might relate to the recent bloom phenomena. Next, current monitoring efforts may lack the spatial temporal resolution, the temporal window, so they might be ending too soon in the year, and the environmental variables potentially needed to adequately, detect and respond to these things. And so one of the most important goals of this project is to determine what some of these things look like for a foundational monitoring program that's comprehensive but efficient. There is also currently no routine cyanotoxin monitoring at high use locations, such as the Barker's Island Swim Beach with past toxic blooms. Um, it's kind of been a more, when you see it, you sample it type of thing, bloom response sampling. And so we'd like to examine when and where this sort of routine monitoring might be most useful for public safety. And so after the 2021 bloom, we started this project. We've been sampling 8 locations throughout the estuary shown on this map. I have the locations color coded by the region of the estuary that they lie within. And once again, we'd just like to point out that Barker's Island site is very important. We sampled these locations over the course of about 2 years, completing 50 routine sampling events at all locations, plus about a dozen additional bloom response sample collections at sites of blooms when those occurred. We measured a whole suite of parameters, including the standard water quality variables, all sorts of nutrient levels, light conditions in the water column, and then collected samples for phytoplankton community enumeration under the microscope. We also deployed high-resolution winter dissolved oxygen loggers in both winters of the project, and then at all of our sites, and then collected samples for colleagues doing tangential work in the estuary as well. And so that got us out there a lot of times of year, a lot of different conditions, anywhere from summer wildfire haze to repairing a snowmobile belt in a blizzard on the ice. And I like these pictures because they really capture some of the just diversity of the estuary, I guess, as you move down. It really is different in the different regions visually. And so we measured many things at many places, many different times. This is an NMDS ordination plot, or non-metric multidimensional scaling, showing some of those results. So on this plot, 1 point represents one complete sample set of all variables collected at one location during one sampling event. This data spans the open water season of 2023. We have 113 observations here. And so NMDS is a tool that allows us to plot and compare these 113 sample sets as points in 2D space based upon the pairwise dissimilarity between all observations. In plain English, points that are closer together on the plot are more similar to one another with regard to environmental conditions. Farther apart, less similar. This is only environmental conditions for now. We're in the final steps of assembling the phytoplankton data set. And so now I've superimposed polygons over groups of points on this plot, or groups of observations on this plot, encompassing all observations for the region of the estuary that the polygon is labeled with. And I also have some photos just kind of showing, once again, visually what it looks like, in those different regions when you're out in the field. I'd like to point out right away, so visually in the upper right, Pokegama Bay, it's a unique, very highly turbid site. And as we can see on the plot with regard to environmental conditions, that site grouped out as very unique from the other sites with very little overlap with in the conditions with the other locations in the estuary. We weren't surprised to see this given just the nature of that location being so unique. But we were surprised that no other individual sites, grouped out so strongly individually. The upper and middle estuary locations were all quite similar to one another with a high degree of overlap between those regions. And so I combined those into one polygon because of the high degree of similarity between the regions. But they were quite distinct from the lower estuary region encompassed in green, which is where the blooms have primarily been centered. But what variables that we measured are driving these differences in conditions, right? So now I've superimposed vectors upon the plot. So each of these arrows or vectors represents one individual environmental variable that's influencing the point placement on the plot. And so basically, as you move in the direction of one of these arrows, you can think of the points increasing in that variable that you're moving in the direction of, and vice versa. So right away, we see a lot of vertical separation between the regions on this plot, different conditions, distinguishing these regions spatially from one another. However, we don't see a lot of horizontal distinction between the groups. So our interpretation of this is some of these more vertically oriented variables, such as specific conductivity, DOC, chlorophyll, appear to be distinguishing these regions more so spatially, whereas the more horizontally oriented vectors appear to be distinguishing regions more temporally within regions more so than between regions. So all in all, this just illustrates, the usefulness of NMDS and similar methods for assessing redundancy of multivariate observations. And eliminating redundancies is going to allow us to streamline our monitoring efforts while, ensuring comprehensive coverage as streamlined as possible. And so we're seeing distinct environmental conditions between different regions of the estuary, but how do the different conditions in these different regions impact what resources are most important for phytoplankton growth in a given region? Well, here's a preliminary analysis I did to look into that, where I used random forest machine learning algorithms to rank importances of predictors of chlorophyll A, which is a common substitute proxy for phytoplankton biomass, as we've heard in a few talks already today. So on the y-axis in these plots, we have our predictor variables of chlorophyll ranked from top to bottom in order of importance. The left-hand plot is for the lower estuary group of sites for that region, and then the right-hand plot is for that combined upper plus middle estuary group. So a lot to unpack here, and I won't be able to go over everything that I would like to go over with these plots. There's a lot of observations to be made, but right away we see very different orders of importance of predictors of chlorophyll between these different regions of the estuary with different conditions. We don't know if this is due to different phytoplankton communities existing in those different regions and thus having different resource requirements. We don't have that data set fully assembled quite yet, or if it's more due to the nature of the conditions themselves, or a combination of these things. But it's very interesting to see just the different ranking of the importances of these predictors. For example, on the right-hand plot, second from the top, we can see NO2 plus NO3, that's nitrate and nitrite. It's ranked second most important as a predictor of chlorophyll in the upper and middle estuary, where that nutrient tends to be more scarce. And we can see it's less important in the lower estuary, where that nutrient is more abundant. And we might think about this, right, like for plant growth, water might be a more important predictor of plant growth in a desert than in a rainforest, where other factors might be important in a rainforest. Is kind of how you can think about this. And so there's a lot more to dive into here. I'm going to move on in the interest of time, but if you would like to chat about random forest, please contact me after this, because I would love to chat with anyone about this further. And so, as I mentioned, we are in the final steps of assembling the complete phytoplankton data set, getting very close to that, but not quite there. It's going to be really interesting to incorporate that data, first of all, to look for assessing redundancy in the phytoplankton communities throughout the estuary, as we did with conditions, but also to look at the relationships between the phytoplankton and the conditions. For now, I'm just going to show you some photos illustrating some of the cyanobacteria diversity we've been seeing in samples so far. So moving from upper left across the upper row, we have images 1 and 2. Those are images of oscillatoria, that benthic cyanobacteria I mentioned previously in the talk. These samples were collected at very different times of year with different conditions at different locations in the lower estuary, but we're seeing this same taxon present. Moving on to image number 3, we see some colonial cyanobacteria present. This was actually a sample collected under the ice in the more nutrient-poor upper estuary in the middle of the winter of 2023. So very interesting to see some colonial cyanobacteria present there. And then the next image, number 4, we see similar looking assemblage of cyanobacteria in the image, but that was collected in September of 2023, one of the warmest water temperature when we had some of the warmest water temperatures we've seen to date in the estuary. So once again, similar looking communities, very different conditions. And then moving across the entire bottom row, there are many pictures of cyanobacteria from bloom response samples. So some of the larger colonial cyanobacteria moving from left to right. We have Aphanizomenon, Dolichospermum, another colony of Dolichospermum, and then finally a large colony of Microcystis from a bloom in 2024. So as we can see, investigating the relationships between the phytoplankton and the environmental conditions throughout the estuary for 50 sample sets is going to be a very interesting challenge, but should yield some very interesting results. Our 2 years of project sampling, 2023 and 2024, had very different weather years, both with the open water season and the winter of those 2 years. And so that gave us a really great opportunity to collect samples in 2 very different years and then compare what's going on in years with different conditions. And so I'm just going to compare and contrast some initial observations, but we will have a lot more to look at here for our final monitoring recommendation report and future analyses with the full data set. So I'm going to start with the blooms. This is a HAB seminar after all. So we saw a different dominant bloom taxa, generally speaking, observationally from 2023 to 2024. In 2023, the blooms almost exclusively tended to be very strongly dominated by Aphanizomenon, pictured in the upper right here. In 2024, we're still seeing some Aphanizomenon in these bloom response samples, but it's far from a clear-cut dominance and potentially dominated more so by Microcystis and Dolichospermum, and even Warneckinia, some other genera of cyanobacteria. We're also seeing blooms starting to occur in new locations, or we saw blooms in new locations in 2024. So the image on the lower right is from near our sampling station at Pokegama Bay, that very turbid location. We saw a bloom there out in the field in late September of this year on a day that we really didn't observe bloom activity elsewhere in the estuary, just that one isolated little spot where we had never seen a bloom before. So very interesting, especially considering the light conditions in the water column there and just the uniqueness of that location. As I mentioned in my overview of the blooms, we did detect microcystin and saxitoxin in both 2023 and 2024 blooms. And then to dive a little bit more into the winter differences. So winter of 2023 was a very cold winter. We had a prolonged period of thick ice cover with thick snow cover on top of it. And in that winter, we saw in the lower estuary numerous under ice diatom blooms dominated by Aulicosyra, a filamentous diatom pictured in the upper left here. Whereas in winter 2024, we had thin to no ice, which really made sampling a challenge that winter. And also little to no snow cover on top of that ice. And the ice did not last for a very long time at all in 2024 when it was present. And at some of those locations where we saw under ice diatom blooms in 2023, we're seeing high amounts of cyanuraphytes. So this is cyanura pictured in the upper right. This is a colonial golden algae. So some community differences in the different winters with different conditions seem likely at this point. And then in the warmer winter, we also saw, so 2024, we also we believe we're seeing stronger diurnal oxygen and temperature periodicity, at least at some locations. So what this essentially means is we're seeing stronger diurnal day and night fluctuation of temperature and oxygen at many locations in the year with the warmer winter in that high resolution under ice dissolved oxygen data that we were collecting. That's what those plots on the bottom illustrate. So those are spectral density analysis plots. The x-axis shows intervals of period length, and then the y-axis is the strength of the signature of that periodicity in the data at a given period. And so you can see on the left-hand plot, there's really no sharp peaks at any given period for dissolved oxygen saturation fluctuations at this site. Whereas in the right-hand plot, we see a very strong peak at a one-day periodicity interval. So that's telling us that we're having predictable, regular day and night swings occurring much more strongly in the warmer winter than the previous year, leading to less stable dissolved oxygen conditions on very short timescales. So super interesting to think about. We're really early in the steps of this little side analysis, but it's looking like it's going to yield some interesting results. So excited to look into this more with our other parameters and our other sites. The stronger periodicity in 2024 with dissolved oxygen could perhaps be driven by physical reasons, less ice cover insulating the water's surface, more daily temperature and solubility swings, or it could be by more metabolic mechanisms, more light reaching the water column during the day when there's thinner ice cover, resulting in more photosynthesis, producing more oxygen, and resulting in more of that day-night regular swing. So lots more to unpack here, but it's looking very interesting early on. And so wrapping up, our next steps for this project, which we are nearing the end of, are to finish our data set assembly. The full phytoplankton data set will be assembled in the coming months here, and then we will be using all of our data to produce our most important product of this project, which will be our monitoring recommendation report this spring, which we will then pass on to local end users to further develop these monitoring efforts. There will also be further scientific analyses with this project data set, including my thesis. There's tons of data that we have here. And so we're really excited thinking about all the different analyses we'll be able to dive into with this. And we're getting started on some preliminary things. And then there's some upcoming projects in the estuaries, also looking at harmful algal blooms, some projects through Minnesota Sea Grant and the Lake Superior Reserve, looking at things like responses to changes in conditions by cyanobacteria, or taking molecular approaches to look at functional genes and genomic diversity, things like that. And so our final take-home messages: these blooms they're a new but worsening problem in the estuary, and currently there are gaps in monitoring, leaving the public more vulnerable to these threats. And so we need to determine when, where, and how to expand routine toxin monitoring and other monitoring efforts for public safety. And we aim to produce a future monitoring program that will be comprehensive, efficient, iterative, and adaptable. I'd like to thank the many folks that have helped make this work happen. I couldn't include any fun photos on my acknowledgement slide because there are just so many folks to thank here. But yeah, we really couldn't have done this without everyone's involvement. So it's been a large effort by a lot of folks. And with that, I would like to thank you all for your time, and thank you to the organizers of this conference. What a wonderful, free, accessible opportunity to learn about harmful algal blooms. And yeah, with that, I'll take any questions you might have. Thank you.
Great. Thanks so much, Peter. One thing I'll just note from the chat, people are very much appreciating the images on your slides. So lots of kudos for those.
I have about 9,000 on my camera roll. So if you're interested in more, contact me.
All right. Awesome. We do have some questions coming in here. So one question is, can you comment on how the large estuary blooms in 2023 may have been impacted by wind weather conditions or drought conditions?
That is a very interesting question. I would say I don't want to speculate on necessarily mechanistically how that may have impacted things at this point, but we did see a prolonged drought in our first open water season of sampling 2023. And we did see long periods of high water clarity, that you would expect in water warming, things like that you would expect in a typical drought year, with a lot more precipitation and colder weather in the early part of 2024. In late 2024, we actually had anomalously high temperatures throughout much of the estuary, though. So, 2023, a very warm drought year, and then 2024 went from a very cold, long spring to a very warm late summer and fall.
So maybe some more of this long-term data will kind of help shed some light on that as you get more,
certainly.
more
Yeah,
years and seasons.
Yeah, we're definitely excited to look into and think about those things. I just don't want to speculate too much at this point.
Yeah, that's fair. No problem. Eugene notes that benthic taxa are notorious for neurotoxins. And he saw that you referenced saxitoxins. Did you test for anatoxins and didn't detect them, or did you not test because of their rarity?
So our bloom response samples that we collected during the pelagic blooms, we did collect toxin samples that we sent to the Wisconsin State Lab of Hygiene. And they analyzed for anatoxin, saxitoxin, cylindrospermopsin, and microcystis, I believe. We did not collect bloom response sample suites at the locations of these benthic oscillatoria blooms. We observed the blooms and identified the taxa that were present. Unfortunately, we don't have toxin data for the oscillatoria blooms, but we would really like to look into the potential toxicity of those, especially given that one of the areas that we were observing that was actually at that Barker's Island swim beach once again. So,
okay, great. Next question comes from Catherine, wondering, was there any type of voucher flora made from the identifications during this study?
I'm sorry, could you repeat the question?
Yeah. So they're wondering if there were vouchers of the flora that were identified during the study. Did you collect any voucher specimens?
So
Like,
we have uh all of our phytoplankton samples that we collected are preserved with Lugol's iodine. And so we have all of those samples archived currently, just in that in bottles in that preserved form.
okay. Are they going to go to a museum or something at some point, or
There are
uh,
no current plans for that, that I'm aware of.
okay. Well,
But
Catherine,
that's a
maybe if
really
you have
interesting idea, though.
ideas, yeah,
Yeah,
about
very
that, you
interesting
can,
idea. No current plans that
yeah.
I'm aware
Okay. A question from Tom. Do you think you could query your data as Sam, the previous presenter, did to see if more sites or more frequent sampling would be most beneficial for monitoring?
that's a very interesting question, Tom. Yeah, I think that's a really interesting idea. I haven't personally looked into those methods too much yet, so I would probably have to do a little bit more familiarizing with those methods. But I know Tom, you're in the area up here, and that's something I would certainly be interested in chatting about. Um,
Awesome. All right. I think that's all we've got. There was another note in the chat about people requesting access to your images. So I think you said maybe email you, but seems like there's a lot of interest if you're willing to share some of those. So
yeah, anyone feel free to email me. Also at the upcoming St. Louis River Summit here in Superior this upcoming spring. I know there's one art display in the works that's going to be incorporating some of these images and painting as
cool.
well. So you thinking about artistic things with these, but haven't really done anything yet. But yeah, if you're interested in images, please reach out.
Awesome.
All
All
right.
right. Well, thanks so much.
Thanks, everybody.
We've got, well, I guess just about a minute. So let me get my slides pulled back up. All right, we'll just wait a minute here before we get started with the next presentation. So we stay on time. All right. I have 2:45, so we'll start our next presentation. Our next presentation is by Laura Kruger, who is a PhD candidate and graduate research assistant at Kansas State University in the Department of Biological and Agricultural Engineering. She completed her master's in biological and agricultural engineering at K-State in 2021. In the fall of 2021, she began her PhD graduate program and is working alongside colleagues on a project focused on integrated modeling approaches, including watershed, mechanistic, and machine learning models for cyanobacterial harmful algal blooms on reservoir systems. And Laura will be presenting today on integrated modeling and monitoring to understand cyanobacterial harmful algal blooms in a eutrophic reservoir system. So Laura, if you want to go ahead and pull up your slides.
Okay. Hopefully you can see those now.
Yep, looks good.
Awesome, thank
Take
you.
it away.
All right, well, thank you for that introduction. And also, first off, I just wanted to thank the organizers of this symposium for a wonderful symposium and as well as the opportunity to speak today. So as was mentioned in my introduction, I'm a PhD candidate here at Kansas State University in the Biological and Agriculture Engineering Department. And today I'll be just talking about a little bit of the research that I've been working on alongside a group of wonderful collaborators that I have listed here on this slide. So just a quick roadmap of today's presentation. I'll just start out with a quick, brief introduction about impacts of harmful algal blooms and the status of harmful algal blooms in Kansas. And then I'll move on into some of our research project goals. Then I'll move into some of the data collection and monitoring efforts that we've done. Then I'll briefly hit on some of our modeling efforts and then wrap up with a quick summary. So this has been mentioned a few times today throughout different presentations, but why are we interested in harmful algal blooms? So, well, in short, we're interested in the potential impacts that are associated with these blooms. So specifically the toxins that may be produced. So these cyanotoxins generally are produced and released into the surrounding environments. And they can be various toxins that can be produced depending on the species present. But for the purpose of this presentation, we're mainly focused on microcystins in Kansas and for this presentation. So cyanotoxins in general can be harmful to humans and animal health, as well as just decrease overall water quality, which can close recreational water bodies and impact the utilization of these water bodies for drinking water resources. And this is specifically an issue for Kansas, as we're heavily reliant on our surface water bodies for drinking water sources. So across many states, across the United States, they've developed these different HAB monitoring programs as a response to harmful algal bloom events. So the statewide program in Kansas is typically active during the recreational season of April to October and monitors public water bodies only when there is a response or a complaint of some harmful algal bloom potentially being expected to be on a water body. And so when a complaint is submitted, the Kansas Department of Health and Environment, or KDHE, will perform a visual assessment and then determine if analytical sampling is necessary. And if they do analyze a sample, they're usually looking for indicators such as the blue-green cell count, as well as the microcystin toxin level. And they've set 3 different thresholds of when they will issue an advisory for that public water body, including a watch, warning, or hazard level. And so these are just based off of different criterions that they have specified for each of those indicators. When a advisory level is met, one of those criteria is met, they will often relay that information to the water body managers and then issue these advisories by posting signage at the water body just to inform the public, as well as they'll post on their website indicating that one of these levels has been met and there's suspected a bloom present, and that access should be limited. And when they have met the hazard level, oftentimes we'll see those water bodies being closed to public access. And so just to kind of get a visual of how this monitoring has been completed across the state and our water bodies. So this map shows all of those, whenever one of those advisory levels is met in our public water bodies across Kansas from 2010 to 2023. The larger circles relate to the higher number of years in which a water body has experienced one of these HAB advisory thresholds. As we look across the state, we can see that many of our water bodies have been impacted by harmful algal blooms. And I'll draw your attention to Marion Reservoir here kind of in the center. Hopefully you can see my cursor, but this reservoir has one of the highest frequency of HAB reports, as you can see by the size of the circle. And then in addition, in 2023, across all of the sample water bodies for that year, it was recorded as having the highest toxin level. And then in 2022, it had recorded the highest blue-green cell count for all of those sample water bodies for that given year. So as we take a closer look into Marion Reservoir and these HAB advisories issued by the Kansas Department of Health and Environment, you can see that across the 92 sample dates from 2011 to 2024, about 75% of those samples fall into one of those categories of either a watch, warning, or hazard for a harmful algal bloom event. And most of the time, these are falling into the warning threshold, so the kind of that middle range pretty, not quite extreme, but the next step below. And KDG does sample at 4 different sites around the reservoir. So this is just kind of on the figure on the right there, showing just how that breakdown of those advisories is for each of those locations. And just to note that if any of these sites meet one of the advisory criterion, then that is what the whole reservoir is getting, that level of advisory, the highest level. So this is kind of where our research comes into play. So the statewide monitoring program is a great resource for public water bodies as for conveying information to the public and getting that information out to the water body users and the managers. However, for like a further understanding of harmful algal blooms, events that are occurring, additional monitoring information is needed beyond that limited complaint-based sampling and throughout the year, not just during that recreational season. Some other factors that would be helpful for monitoring include nutrients, environmental conditions, and other factors. And really just focusing on developing a more time series continuous data set would be helpful. So with that additional monitoring data, we can hopefully start to better understand some of those knowledge gaps that are existing in freshwater harmful algal bloom events, such as what's triggering these blooms to onset, what conditions are helping sustain these blooms, and then why are some of these blooms toxic or not. So that's where our project is coming into play here. So this research aims to expand upon the current monitoring data sets that are collected at Marion Reservoir in order to just better understand some of those conditions that are present and the dynamics of the harmful algal bloom events that are occurring. And then through a collaborative effort, we're hoping to integrate that site data into several different models, including a watershed model, a lake model, a cyanobacteria growth model, as well as some machine learning based models. And really with this modeling effort, we're just trying to leverage some of those strengths from those multiple different models to develop a clear understanding and potentially predictions of harmful algal bloom dynamics that are occurring in the reservoir. So while this is a collaborative team effort, today I'll mainly focus on the data collection and site monitoring that's been completed, as well as I'll briefly hit on some of the pieces of the watershed model development that have been done. So as you might have guessed, our study location is Marion Reservoir. Marion Reservoir is located in Marion County, Kansas, which if you're not familiar with Kansas, the subset map here shows you kind of that location of where the reservoir is in Marion County. So this reservoir was completed by the U.S. Army Corps of Engineers in 1968 with the main purpose of providing flood control, but is also used by the surrounding communities as a drinking water supply and is used for recreation for fishing and boating and some waterfowl. So approximately 200 miles squared will drain into the watershed or drain to the reservoir from the watershed. It's predominantly agricultural land as well as grassland. So as I mentioned, one of our project goals is to expand upon the collected monitoring data set that is at Marion Reservoir. So this includes a variety of sampling, including discrete sampling at 7 discrete sites around the reservoir. They're mostly spatially distributed around the reservoir, and we aimed at sampling these sites every 7 to 14 days from 2022 to 2024. And in the winter months, we did generally got at least one monthly sample during those months. So some of the data that we're collecting at these sites include a suite of water quality parameters, including nutrient information such as nitrogen and phosphorus, some sediment information of total suspended solids. We're analyzing for the microcystin toxin. And then we're also using a YSI multi-parameter sensor to drop in and collect data of in-lake parameters that I've listed here at each of those sites. And so I'll go ahead and note that we have a similar YSI sensor that is installed here at the front of the dam. I'll talk about that next, but just to give you a location of that, it's right here where it says buoy approximate. So in addition, we have this continuous monitoring data. So that is that sensor that we have installed in a buoy that's housed right down here in this metal housing of the buoy, is in this picture on the left here. And it is collecting the similar variables that I just talked about on the discrete sampling of those from the sensor, the YSI sensor. We're collecting those at hourly intervals. And in addition to that, we have a kind of like a profile depth of temperature and light using light pendants, just to get a better understanding of some of that temperature and light distribution throughout the column of the water body there near the dam as well. In addition, we're collecting supplemental environmental data sets from the U.S. Army Corps of Engineers climate station that's located there on top of the dam, just getting some more information about weather information and reservoir information as well. And so for this continuous data, it's continuous but near continuous. I mean, we have it installed usually by April and then going usually till October and November, but we did have some issues that we had to pull it early one year. So just to kind of get a look at some of that data that we've collected over those 3 monitoring years, I'm highlighting here on this slide the data that we've collected with that multi-parameter YSI sensor that's housed in that buoy, specifically the chlorophyll and the phycocyanin values that we've collected. And so just to note that these are both optical measurements that are reported here as relative fluorescent units. So the chlorophyll is that measurement of all the green pigment produced by algae and cyanobacteria, and then the phycocyanin is that accessory pigment that's produced by cyanobacteria specifically, but we're using as an estimate of cyanobacteria production. And then on this graph as well, we have those vertical green bars, and they just are a gradient of color that are indicative of when KDHE went out and sampled and the reservoir was in one of those 3 advisory levels for a bloom being present. So in 2022, we see that first call out there, the reservoir was actually in a hazard level warning, and we do see a peak in our phycocyanin values there, so corresponding with that. And in other years, we hit mainly warning and watch levels, and we did see some similar peaks in our phycocyanin values throughout the year. So now I wanted to share some of our discrete sampling variables that we collected at those 7 sites. And the figure on the right just is that map again, just a refresher of where those sites are all located. But here we completed a quick correlation analysis just to start exploring some of those relationships that are existing between the environmental data and water quality samples, variables that we're comparing to microcystin as a bloom toxicity measurement, and then also phycocyanin as like an intensity of a bloom. And so when we start looking at this figure, just to orientate you, across the top is that microcystin value, and then the column, as we go down in each of those rows, it'll be all of the different variables that we have. And this first column here is just across all sites, so no matter the location. And then each of the other ones are broken down by the specific site. And so we start to see some of those relationships popping up of between microcystin and the nutrients. So those larger and darker colored circles are a higher correlation. And we specifically see that, especially with our nutrients with nitrogen and phosphorus, especially at the dam front in Marion Cove, which are located right here down near the front of our dam where our buoy was installed as well. And we also see a strong correlation with the microcystin with phycocyanin. So as we look at how phycocyanin compares to all of the variables, we see a similar story. We see a similar strong relationship of the nutrients with phycocyanin. And this is just starting to like pinpoint at some of those variables that are maybe showing that relationship of when the bloom is toxic or the intensity and presence of the bloom, just getting a better insight of how our data set's responding. And so pinpointing at those nutrients specifically. So now I'll move into some of the modeling, as modeling is another major component of our project. And today, just for time constraints, we'll just briefly cover some of the work done with the watershed modeling development. So we're using the Soil and Water Assessment Tool Plus, which is SWAT Plus is how it's often referred to as. So SWAT Plus is a hydrologic modeling tool that utilizes various input layers. So it utilizes land use, soils, and topography or elevation. So the digital elevation model is what we use here. And so this digital elevation model can be used in the watershed delineation step, in which it creates streams in a channel, so a stream network. And this stream network is used to delineate the watershed down into further subbasins. So here we delineated the watershed down into 14 smaller subbasins. And then the next stage of model development is development of these, what's called as hydrologic response units. So within like one of these subbasins, it's looking for any land area that has the same land use, soil type, and slope. And it's combining that into one, those areas all into one unique identifier which is a unique HRU. And so we use that unique HRU in order to define land use management and schedules in further model development stages. And so I'll go ahead and describe that on the next slide. So in the next stages of model development, we're defining that land use management and schedules to each of those unique individual hydrologic unit codes, HRUs. And so this is where we're really trying to make the model as representative as possible to the current watershed characteristics. So trying to represent those typical crop rotations that we see in this watershed. We see soybean and corn rotations, as well as some double cropping systems with winter wheat and soybeans, as well as we can represent different grazing operations as well. So once we've defined all of these in our model, the model is ready to be ran and calibrated. So we're using a flow calibration for this analysis where we're comparing the simulated flow from the model to an observed USGS flow station. And so once the model is sufficiently calibrated, we'll be able to use that to simulate various conditions. So various conditions that we can use are such as like different land use changes in crop rotations, different management styles, maybe like no-till or any conservation practices that we can integrate into the model, as well as understanding some of the impacts of climate that would have on the watershed hydrology. And ultimately, we're hoping to better understand the role of the impact or the role that these impacts are having on the watershed hydrology and ultimately onto the state of the reservoir. So maybe when those bloom events are occurring. So I just want to go ahead and quickly wrap up. In summary, over the 3 years of data collection and site monitoring, we've provided more robust insights into conditions that are present at Marion Reservoir and all throughout the year, as well as during those harmful algal bloom events. So we know that there's many factors that are leading to bloom onsets and toxin production, and they can vary. So with analysis of our monitoring data, we'll continue to help pinpoint down to those sets of variables that may have the most influence. We're already seeing strong correlations in those nutrient loadings with when we compare that to microcystin and phycocyanin. And so that's just kind of showing the importance of managing nutrients, both nitrogen and phosphorus, as it's coming into the reservoir. This collected monitoring data set that we've put together is already being utilized to inform model development stages, including that watershed model that I have talked about, but as well as the other models that are collaborators on this project that are working on, including the lake and cyanobacteria growth model, as well as those machine learning models. So overall, we are hoping to just gain a better understanding of these harmful algal bloom events that are occurring both now and then those that will occur in the future. So with that, I just want to thank those who have supported this research, especially those that have helped with funding, including the USGS in support of this. And then all of those that have helped either through collaborations or serving on my committee, as well as those who've came out and helped with field sampling and sample processing. It's very important, a work that's been very helpful and invaluable. So just a quick thank you to all of those. So with that, I'll take any questions and be happy to answer any questions you have also later via email. So thank you.
Great, thanks a lot, Laura. That was a great presentation, and we do have a couple questions coming in, and if people have more, just feel free to keep putting them in. So first question is, have you compared your YSI sensor measurements for chlorophyll and phycocyanin to other methods to see how accurate it is?
Yeah, great question, and thank you for that. So we have on a little side, in 2024, we did collect samples that we could run chlorophyll in the lab and get lab-based measurements so we can compare that with the optical measurements from that sensor. So that is something that we have and we're working on. I didn't present it today, but be happy to, if you want to reach out, we can talk about that some more. But yeah, that's in the works still. For the
Awesome.
most part, it seemed like it matched up decently well.
Okay, great. And then another question from Carrie. Did you do correlations with chlorophyll A as you did with the microcystin and phycocyanin? Did they correlate with the same nutrients?
Yeah, we did correlation with that chlorophyll A as well. They didn't have as strong as relationships as we saw with phycocyanin and microcystin, but they did have some at the same locations. That would be something I can look into more too as well. But yeah.
Okay, great. Well, I'm not seeing any more questions at the moment, so if people have more, go ahead and throw them in right now. Otherwise, I believe we have a break next, so let me pull up my slide that shows that. Okay. So we are now on a break, and our next presentation will start at 3:30 Central Time. So we look forward to, we'll be leaving this open, and we look forward to seeing you after you get some coffee or tea or anything else you need. Welcome back, everyone. We're just going to give it until 3:30, and then we'll go ahead and get started.
I can toss my slides up.
I actually have an intro slide for you first, so.
Oh, okay.
All right, welcome back for our last two talks. Thanks for sticking with us. Let me get my slides forward here. Our next speaker, hang on, the window the right way. All right, our next speaker will be Jeremy Foote. Jeremy is a senior wetland scientist with TRC. His background is in geoscience, grounded with surface water quality and wetlands. He is currently pursuing his PhD in plant biology at the University of Massachusetts Amherst, where he is working on developing methods to monitor the nitrogen status of cranberry bogs via drone-based remote sensing technology. He also is a certified SUAV pilot. And today, Jeremy will be talking to us about Are Drones Worth It? A comparative cost-benefit analysis for water quality monitoring. If you want to go ahead and pull up your slides.
What is going on, friends? All right, we can see everything?
Yep, looks good.
Perfect. What's going on, friends? My name is Jeremy Foote. I'm a senior wetland scientist with TRC, and we're here to talk about drones and the comparative cost benefit analysis and what drones can bring and would possibly bring to the monitoring and detection of algae blooms. This is not a solo project for me. This was done, there are a lot of people to thank for this, including other, there it is, including other people at TRC. Teamwork makes the dream work, and, everything, collaborative. And so what we're going to talk about is we're going to talk about conventional field sampling versus SUAV sampling or drone sampling. There's a lot of different kinds of drones that there's a lot of different drones out there that you can use. There's aerial drones and aquatic drones. And even within aerial drones, there's fixed wings, multi-rotor, like helicopter and hybrids. We are just going to focus on your sort of basic drones that everybody thinks about when they're talking about drones, which is your basic helicopter drones. And so what can drones bring to harmful algae bloom detection and monitoring? Well, they can bring as much or as little as you want. It can be as complicated as you want it to be, or as complicated as you have the money to make it. That's sort of one of the big limiting factors about what you want to do is a lot of it kind of boils down to money and what you can afford to do. We can start off with real simple, just aerial images for visual monitoring. I mean, that just includes a real basic drone and a laptop. A laptop to look at image and splice images. Like I got a drone very similar to the one on screen for like $200 at Costco. You can use that to visually monitor a lot of your physical properties that you can just see, like your turbidity, algae blooms, where they're moving, the size that they're doing, and the like. Or you can go one step further and get drones that can carry heavier payloads uh, and place various sensors on them, be it multispectral sensors. So you're looking at and sparse out different wavelengths of light. Here's one that's got RGB as well as a telephoto, a near infrared, and a second, and two different near infrared sensors. You can use those to sparse information out on different wavelengths, especially in the infrared. And those drones tend to be a little bit more expensive. And then with the sensor packages, you're looking at starting at around $1,000 and going up from there. And then the imaging and process analysis software, it can start at anywhere from a $300 annual fee. But with that, you can start doing more analysis of like what kind of chlorophyll activity you're looking at, what kind of algae you're looking at, and you can get a little bit more detailed picture of what the algae is doing. And then you can go, research level. Like this is some of the stuff I work with. Like this is upper bounds research level equipment where your drone can carry up to 15, 16 kilograms of sensors and weight, and you can put, very high very high yield hyperspec sensors that will collect data from the visual spectrum to the near IR. From that, you can do a lot of different things. You can also, use LiDAR and use, thermal radiation sensors on these kinds of drones, and those will give you extremely high-end data. But for the kind of work we're looking at doing was just monitoring the growth and the transport, the growth and the movement of these algae blooms, you don't need to go that far. The first option is a very reasonable option for what we're trying to do. So what do we want to do? Like, why are we looking at, what are some of the reasons for using a drone versus in situ? We look at in situ sampling and boat deployment. I mean, boat deployment's not, it's not a big deal, but it's another thing to do. Boat deployment, limited access points. We're working on, like, I do a lot of work out here in the Massachusetts, New England, Rhode Island area, and we have one boat access for a very large reservoir, and it takes a good hour to get from the boat launch to the reservoir, where if we were able to just pull off to the side of the road, pop a drone off and take some quick pictures, it's a very different, very different deployment strategy. Not only that, but cruising through these algae blooms, you are creating more water disturbance. You have a chance of spreading this stuff, and you don't want to do that. But on the plus side, in situ, you get a lot more details. You can take a lot more water samples. You can take a lot more depth samples. But when you're looking at the bigger picture of an algae bloom, it's hard to kind of get the spatial scale of what a current bloom is actually doing. And when you're on the water in a boat, that's really kind of hard unless you're going to do a really detailed, extremely long, systematic water sampling regimen of the entire pond. And then you're also pulling the boat in and out, and you're running into scenarios where you're going to have to decontaminate that boat. And the more places you take that boat, the more times you use that boat, you kind of, all the decontamination in the world, there's always the possibility of cross-contaminating, into other protected waters. And we don't want to do that. We're here to protect the waters. So why do we use drones? Drones are great. They enhance accessibility. You can fly the drones wherever. You don't necessarily have to have a boat access point for what if you want to do something, you can get high resolution, real-time data. The versatility of capability is extremely variable, like we'd said in the previous slide, where you can have different payloads for what you're looking for. And it's also very minimal disturbance. So you're not actually getting in the water. So you're not, physically spreading, kicking up sediment, moving the bacteria around, moving the algae bloom around, anything like that. You can get an accurate picture of what the plume is, and that goes forth with the more accurate spatial extent. When you're flying the drone above the pond or the reservoir, and you're making a systematic survey with images, you can splice this together, get a really good idea of what your bloom looks like, what it's doing. And if you take those over time, you can see how it's growing, how it's shrinking, where it's moving, with the possibility of being able to sort of track where maybe some of the higher nutrient water is coming from. Like, where do you see it as thickest and where does it peter out? You can start to sort of track where maybe some of this point source is coming from. And so one of the cost benefit analysis for drone deployment is, like, what does it cost to do everything? For a lot of people are really hesitant to look at drones because they see them as a big upfront cost, in which that's true. There's a little bit of an upfront cost, but I mean, you have the same upfront cost as you're doing everything else. Buying the equipment, where you're buying drones, you're still buying boats. Where GPS meters are GPS meters. It's the same thing with field staff. You're not going to go out in the water and sample with just one person. You're going to have two people with fields. You're going to have two people to go out with field staff, and it's the same thing with going out with flying drones. You really should be going out with two people, one for piloting and one to act as an observer to make sure that what's happening around the drone, because the pilot will be focusing on what the drone is doing, and you're going to want an observer out there to monitor what's going on around the drone. So it's just safer that way. Both have periodic site visits, and the nice thing about the drone-based versus the conventional methods is that the drone-based, there's not as much prep time when you're just going out there to do a quick visual survey of what is happening in your pond. So some of the cost breakdowns we have, versus, initial equipment cost versus recurring costs. And one of the things that it's always important to keep in mind is, as of now, like, using drones to monitor these kinds of things is not something that's going to replace boots on the ground, boats in the water sampling, very soon. I believe that we're very much on the cusp. We'll kind of get into that a little bit later, but aerial monitoring and drone use is not going to completely replace yet boat monitoring, but early detection equals early analysis equals early treatment. And it's a lot cheaper to go out on a regular basis and just do a quick fly over a pond than going out with a boat multiple times and taking multiple samples over and over again. The nice thing about the drones is that it really sort of decreases the repetitive cost over and over again, because once you get the drone and once you get your trained pilot and your observer, it's a lot cheaper to go out there for a couple of hours, fly around, and go home, instead of mobilizing a large sampling event. And so when you're looking at when there's an actual algae bloom, like, sure, you're not going out and you're not testing for everything. You're not testing for what kind of actual bloom it is, what kind of bacteria it is, or anything like that. You're just getting a general idea of where is this bloom, where is this bloom, where is it going, what's it doing, what's the size of it, and possibly where it's going. And that's where the drones really become useful in that kind of area. and so you get your conventional versus your drone-based costs, and this is more for repetitive. And like I said before, it's not going to replace manual sampling, for determining a lot of these parameters that you can only get when you're taking physical samples. But as a monitoring approach, an early detection approach, this is really handy and really useful for that kind of thing. And so, yeah, we'll kind of go into the different ways you can use drones and how the different data you can collect through drones can help. And so here we're looking at a number of different examples of the different information you're going to get from drones. And so from your aerial drone, you see the top above the visual, you see an active plume forming. You can tell by the way the water's flowing and the way you sort of have the break in the plume on the other side of this dock, that you can kind of get a general idea of the general flow of the water and where this plume is heading. That's one of the great things about using this. When you do that over a large pond, you can get a much better idea of the scale and movement of your bloom. And we go back to looking at some of the causes for these things. Like if you're actively monitoring, like you're going out once a week to fly your pond, your lake, or your reservoir to look at this, you can get an idea of what might be happening. Like, one of the things, like, so when one of the earlier presentations, Dr. Chen, he brought up, using the Morris, Aqua, and the Terra satellites as regular monitoring and, monitoring and early detection for these kinds of blooms that are coming up. And those are great. Those are absolutely wonderful tools. But the problem is that, this is satellite based information that you're gathering, and the smallest resolution you're going to get from the Morris satellites are about 250 meters square, which equals out to about 15 acres. And I know there's plenty of ponds that out there that we're watching that are smaller than 15 acres, and you're not going to be able to get any real information from a 1 pixel that covers your entire pond. And not only that, but it's covering the entire planet in 2 days, and so it takes some time. And so relying on satellite imagery may not necessarily be as advantageous to being able to, we think there's a problem, let's send a crew out there tomorrow with the drone, because with the satellite you're fighting cloud cover, you're fighting aerial conditions and all these other conditions, where at the drone, since it's so much lower and active, is that you can do it and you can collect that data right away and look at what you're looking at. And so in some of the prevention context that we're talking about, we can monitor some of the inflows. And so say you have a number of inlets into your pond or stream that you have that you can routinely monitor. Like the bottom of the visual, we're looking at an image of an inlet into a river that is highly, that has a high level of turbidity. And you can monitor that. Let's say there's a wildfire in the drainage basin, you can start monitoring some of the inlets into your pond or reservoir or lake, and start to see when your turbidity really starts to rise. Because as rain flushes all the sediment from a wildfire down into the stream system, and it flushes it into, and it starts to drain out into your pond, you're going to be able to see that turbidity rise. And you can monitor for that kind of thing to sort of get an idea of how bad the turbidity is, where it's going, where it's coming from, and how it's dissipating. And so that's one of the other, even with just your real base visual drone monitoring system, you'll be able to do. And the next we move forward to a little bit more complicated, a little bit more expensive monitoring, which is with our RGB band ratios, where you have it's not just a camera where they're actually taking wavelengths of light in the red, green, and blue wavelengths. And then from that, you can start doing different band ratios. And in the RGB band ratios, we're looking at how they've oriented the band ratios in a way that make chlorophyll really pop. And in this one, we're looking at where algae is, and they're basing that on the chlorophyll reading they're getting from an RGB band ratio. And you can see that most of that's just water, but you see up in the circle, you start to see an algae bloom start to manifest itself. And, it's like an early detection, early treatment, early preparedness. And that's kind of what this is all about, is making a cheap, effective way to monitor. And then you can get even more complicated with your multispectral sensors, where you can really start to dial in, surface chlorophyll, especially since the chlorophyll A is really, really on their surface is really easy to detect. You can start using the chlorophyll, concentrations to map your concentrations of the algae blooms. This is from a paper. I'll have some of these references. I have all these references that if you're interested in reading later. And so that's kind of where we're at as far as like a detection and monitoring. And so that's one of the great things about, using drones in this way is it kind of makes repetitive routine monitoring on a visual standpoint extremely useful. But I mean, what's next? This is a technology that's very much evolving. And these are all examples of current drone-based water sampling and monitoring solutions that have been published about. And I think we're very close to seeing, very real solutions because these are all specifically designed ways of sample collecting that were designed for these specific studies. But there's enough of these out there, and this has become an interest that I think we're very close to being able to capture and sample via drones, which is give you a lot more access, and you can go out, collect a sample, come back. We've got our multi-sample collector like this guy. I don't know. Can you see my mouse? I don't really know. Um, so this guy, multi-sample collection, flies out, is able to collect 3 different samples off of one flight. This one you can collect, drop it. Like we're all familiar with this kind of water sampler. Drops it down to a certain depth, opens up, collects the water, closes it, flies off. And what you can do is you can have a whole system set up where the drone flies out, collects water, comes back. You switch out the tanks, do the sampling, and switch it out. And then you have other drones that are set up with sensor packages. We have our number 6 over here, where that's got tubes and all the different all the different sensors and pumps that you might want for some of the different parameters you're looking for. And this one is just a simple depth profile. It just flies out, drops down, takes a depth profile, flies out. And so if you're working with a shallow pond, and instead of going out with, using ultrasonic, to go out and map the bottom, you can just drop down, move. And so it makes a very simple solution. So that's kind of where we're headed. And I think as we start to integrate, and that's why we kind of want to integrate these kinds of technologies into our monitoring program is when our sampling and more water quality monitoring becomes more readily available. We already, we have the experience and the know-how and the setup to be able to go out and start implementing some of these packages, which will make, sampling and monitoring a lot easier. And like a great example, in, our next spot is treatment. This is like some of the work I work with on my PhD is working in tangent with drone-based fertilizers. And this is a drone. This is a much larger drone than any of the drones. This drone, I want to say, is 5 feet. It's got a 5 feet span from like tip to rotor to tip to rotor. And these guys, just to make sure that I don't blow anybody's ears off. Here we go. But so these are set up with predetermined paths to go out and drop either granular fertilizer or spray fertilizer. And so you can adapt these, like you can adapt a solution like this to algae control, where you can, assuming, you have the proper pesticide permits and stuff like that, you can send this out with an algaecide or a herbicide to pre-treat a bloom that you're starting to see. So, that's where we get back to early detection, early treatment, where using your, cheap routine monitoring, you see something starting to take a hold, and you can, treat it early, treat it fast, to keep it from becoming a bigger problem. And so, that's what we're looking at, and that's what, we're going. And so drones, it automatically played. Look at that. So, is drone-based monitoring worth it? And, it depends in a lot of ways, but do you have a drone pilot in the software? There's a lot of really cheap options out there. And so we can assume that yes. And like, are there recurring water quality challenges that are expensive to monitor? Probably, Is the lake small and beautiful? No current water? Like, probably not. And then do you manage a large reservoir that anticipates to experience future water quality challenges? Probably. We've heard plenty of examples today of how climate change is starting to interact and affect all the different water bodies we're working with. And so using drones is a cheap not a cheap alternative, but a cheap method for routine monitoring is an extremely, is an extremely positive thing to try. So this is just the image credits for the image I used, because I used it from a lot of papers. If anybody wants more information, feel free to email me. I can happily give these images out. I took the video. It was at the Cape Cod Cranberry Growers Institute annual meeting a couple of years ago. But yeah, that's all I have. Yeah, if you have any questions, feel free. I'll stop sharing.
Great. Thanks a lot, Jeremy. We do have some questions coming in here. So first question, I have limited knowledge of drones, but I thought I had heard that drones have difficulty navigating over water. Is there any truth to that? Or maybe perhaps it's that the stakes are high operating over water. If something goes wrong, you could lose the drone in the water.
And that's always that's always sort of the risk of using drones in any kind of scenario. Like the big risk for using drones over water is, yeah, something could happen, it could fall into water, and it's not that recoverable. But a lot of the drones these days, I think it's safe to say that all drones, unless you're buying like really super cheap drones, have like automatic return to home. Like every drone I have and I have used, if like your battery level drops to like 25%, the drone's like, I'm done, and it flies home automatically. And you can change that depending on your comfortability. Like if you don't trust 25% or your battery is older and 25% actually disappears a lot faster than you think it should, you can up a lot of those settings. So you can set it like if it's at 30% or 40%, I want you to come home. But so there's no technical reason why drones have difficulty flying over water. If anything, they fly better over water because a lot of, like, if you have preset paths around water. So let's say you have a preset path set up so you can systematically take the same photos over and over again every time you go out to then splice together and get a good picture of your entire pond. That's all via GPS. And when you're over the water, there's nothing above you. I mean, unless you're flying under the random high electricity wires, which is very random. But in general, you're not going to have any GPS interference over a pond or a lake because there's nothing above you. And so it's actually a lot better for the GPS to keep track of where your drone is instead of flying it, under trees or anything like that.
All right. And then continued on that kind of logistic front, somebody's wanting for the smallest and cheapest types of drones. Like, is there like a max wind speed? What is their operating distance? Any thoughts on that?
And that's kind of what for the cheaper. So like the $300 the $300 drone. It's it's a DJI Mavic Mini 3 that I got at Costco for like $300. It can hover in winds up to like 20 miles per hour or something like that. But the heavier, that's one of the things to keep in mind. The heavier the winds, the worse the weather, the harder the drone is going to have to work to stay in its spot. Like I have a video where my drone is staying on location, but the video is like this because the drone has to fly at an angle in order to counteract the wind push in order to stay. And so all of that, so there are limitations, and a lot of that has to just do with battery and the radio signals, like the Wi-Fi or the Bluetooth signals that the drone is coming with. And all that is very well spelled out on any of the drones that you're looking for.
Okay, great. A question from Tom. I believe one challenge with drone monitoring is archiving, managing, and sharing the very large data sets. Everyone is collecting imagery, but no one knows who already collected imagery in the same area, and sharing is limited. Can you comment on that? Cloud storage can be pricey, and who should pay for the long-term archives?
That is tough. Like cloud storage, it's the nice thing about cloud storage is it exists and it's fantastic. But you're right, it's very difficult. I mean, we have that At TRC, that's an issue we're constantly dealing with, is we are collecting these large data sets, these large drone images, which are gigs and gig size. And where do you store them? How long do you store them for? Who's paying for that? And so, in your smaller operations, it would be better to have more, like your cloud solution should be more what images you have and where they are. And then those large storages should be more offline, because like the cloud storage, right, is extremely expensive. And moving those images around, once you put the images together and you have one coherent image, that's 100 gigs. You can't easily just download that on you can, but it takes forever, especially if your internet's not great. Like if you're out in the middle of nowhere, so a lot of that kind of stuff, in my opinion, is better to keep more locally and then just have a really good, like that's kind of up to the organizations to talk about and communicate, to mention, and to organize. So like if you're organizing sort of like a citizen science kind of thing, because I kind of feel like that's kind of what the question is. Then you just, that's where you can use like your Google Forms, use Google Spreadsheets. You can have like a real basic website set up and just make sure people know what's been done, what can be done, and stuff like that. And so, when you're dealing with those large data sets, I think keeping it locally and offline is probably your best bet, because you're right, it can add up real fast especially if you're trying to, in the money saving department.
Yeah. Another one here. John is wondering, can drones today reliably take grab samples of water from the surface or from any depth? You mentioned
I mean,
that, but
any depth is a little tough, because
okay.
any depth is a little tough. I mean, the papers that I had mentioned, the images that I had for sample collection, those were specifically, like, a lot of that equipment was specifically designed for those research experiments as a combination of proof of concept and the data they wanted to collect for their research. I am not towards I am not familiar with like a commercially available package that you can go out and buy to attach to a drone. And one of the difficulty, and so one of the things to keep in mind is that your payload. And so when you start collecting water samples, that starts to get heavier and heavier and heavier. Like one of the things that we're playing around with is using just a smaller, cheaper drone to go out and drop like a Saki disk going down, and you can just watch it, get an idea of, to be able to measure turbidity that way in various stages. But again, one of the things you have to remember is, that thing will sink by itself, but then you got to pull it up. And some of these drone payloads are not great. So that's kind of where the hesitant is. But drone motors are getting more powerful, batteries are becoming a lot better, and I think in the next couple of years, I would be shocked if we didn't see commercially available items for water grab samples.
All right. One more here, and then there'll be some more in the Q&A pod if you have time to type in any answers after this. The federal government has expressed some hesitancy regarding potential security concerns for some drones manufactured overseas. If they are really considering a ban or restrictions, how much do you think that might impact this kind of research?
So and this is a question we've had at TRC as well, and one of the biggest effect this is going to have is on the cost of the cost of acquiring this kind of equipment, because like one of the big the big discussion is about DJI drones. Like as an example, like DJI drones, they're manufactured in China, and that's one of the major manufacturers. The federal government, the federal government can't they can't purchase the drones, and they can't use it for federal government work. Like there's been discussions about even limiting private, private firms from utilizing foreign-based, China-based drones on infrastructure projects. That's not something that's happened yet, but that is a discussion that's happening. So as far as its impact on research, the impact is going to be the cost, because there are drones. It's called the Blue List, and it's a list of drones that have met the criteria that can be purchased by federal entities and be used on federal entities projects. Because it's not just a matter of being purchased by federal entities; it's being able to be used on federal entities. So you could be if you're a subcontracting through the USGS, we're just saying USGS as an example, being subcontract through USGS to regularly monitor a pond, it's likely they won't let you use your DJI drone because it's a DJI drone. So you'll have to acquire different drones that meet the approved list. And the problem is that those are a lot more expensive, and that's kind of where we're running into some of these difficulties, is that the cost of entry is becoming a lot higher. Now, hopefully in the coming years, as more competition, and this has sort of been a thing for a while, we'll be able to see the price drop. But that's really where the restriction comes in, is just being able to purchase these and use them on these different projects.
All right, great. Well, thanks so much. And yeah, if you want to take a look at the Q&A, there'll be more questions in there.
Yeah.
Gonna get to our last presentation. Thank you. All right. Jenna Whitaker was the 2024 Freshwater Fellow at the Lake Superior National Estuarine Research Reserve located in Superior, Wisconsin, and is currently continuing her research as a research technician. In December 2024, she completed her Bachelor of Science in Biology and Environmental Science at the University of Wisconsin-Superior. Jenna's fellowship research focused on evaluating the accuracy of rapid test strips in detecting microcystins, a toxin commonly produced by cyanobacteria in freshwater ecosystems. Her work aimed to better understand how these rapid test strips can be used for monitoring water quality and protecting public health. And today, presentation will discuss the accuracy of rapid test strips for the detection of cyanotoxin microcystin LR. Go ahead whenever you're ready. You can go ahead and pull up your slides.
Is it still not in presentation mode?
Not yet.
Okay.
I think, yeah, if you hit that little play button. There we go. Yep.
All right.
Looks good.
All right. Hello, everyone. My name is Janae Whitaker, and today I will be discussing my research on the accuracy of rapid test strips for the detection of microcystin LR, which is a toxin commonly produced by cyanobacteria, also known as blue-green algae. And if you're not familiar with blue-green algae, this image up on the slide is an algal bloom event we had here in Superior, Wisconsin this past summer. So that's a great visual of what blue-green algae can look like. Over this past summer, I had the opportunity to create and conduct an undergraduate research project as the Freshwater Fellow at the Lake Superior National Estuarine Research Reserve, which is located in Superior, Wisconsin, which is at the western tip of Lake Superior in northwestern Wisconsin. Superior is bordered by the bays of the St. Louis, Superior, and Eloise, along with the rivers of the Nemadji and the St. Louis. With being located near these water resources, recreation in this area certainly flourishes. However, the increasing frequency of algal blooms in our characteristically low nutrient and pristine cold waters poses health risks to people and the environment. My research project was to analyze the accuracy of two brands of rapid test strips in their detection of microcystin LR, which is especially of concern in my area that my research occurred in. The brands I utilized were 5 Strands and Gold Standard Diagnostics. Rapid test strips are a management tool that can enhance mitigation efforts to prevent public health risks and decreased water quality. They provide quicker results than traditional laboratory testing methods, helping to make informed decisions for beach closures rather than waiting days to weeks for lab results or forcing beach closures while waiting for those lab results. And both of these impact local tourism. Now, before I get into the methods and results of my research, I would like to introduce you to the test strips. This is the test strip provided by 5 Strands. The water sample is lysed through a chemical reaction that occurs within the provided sampling container. I have included both a positive and negative test result here. When a line is absent from the T, which represents the test line, the test is negative. Whereas if there is a line present in that spot, it'll be positive. And a line must also be present in the C or control line spot for the test to be working properly. Otherwise, it is considered inconclusive. Now, this is the gold standard diagnostic test strip. And these are a range of results using the gold standard diagnostics test strips. The water sample is lysed through multiple stages of a physical shaking process using reagent paper and vials. The test strips provide a quantitative analysis of the water sample. It will indicate a positive or a negative result, but it will also indicate the amount of toxin present in the sample with a color gradient in the test line. The test line is the rightmost line shown and the control is on the left. And it will indicate with a color as long as that toxin concentration is within 1 to 10 micrograms per liter, because that's what's indicated by the company. And you can see there that the one on top represents a negative and the bottom is a high. And you can see that as that concentration of toxin becomes higher, the color will get lighter, just to reiterate that. So the accuracy of these test strips were tested through analyzing if the results are impacted by water quality parameters, what the detection limits of each brand are, and the consistency and natural sampling of algal blooms. The first experimental trial tested toxin-spiked natural water samples of known microcystin LR concentrations. Water samples were collected from 3 sites within the St. Louis River estuary, which is where the St. Louis River meets Lake Superior. These are the sites that the Lake Superior Reserve has collected data on since 2012. The sites chosen were Barker's Island, Oliver Bridge, and Pekegama Bay. The natural water samples were collected with a triple rinse with sample water downstream of where the sample would be collected to help reduce possible contamination. Once taken back to the lab, the samples from each location were treated with a spiking solution containing microcystin LR at 50 micrograms per liter, which was later diluted to reach a targeted concentration. The control had no spiking solution added, so it was just the natural water samples. The low was spiked to be 8 micrograms per liter, which is the concentration recommended as the EPA's recreational standard. And then the high concentration was spiked to be 15 micrograms per liter to represent well above advisories to protect human health. So this would be very unsafe conditions to go swimming in or recreate in. The concentrations were then analyzed with replicates for each treatment and brand according to the instruction materials provided by each of the brand's test strips. Additionally, prior to sampling, a multi-parameter sonde was used to collect water quality conditions of each site, including chlorophyll A, dissolved oxygen, pH, specific conductivity, temperature, and turbidity. The data from the date of the sample collection that was used for the spiked solutions is indicated with the dot. And then the historical data collected by the Lake Superior Reserve of the mean annual summary of these different parameters from 2012 to 2023 is indicated by the box. This gives a good comparison of how things have changed over time, but more importantly, this shows that the sites vary from one another, which may influence how the pollutants behave within these water sites, leading to improper test results. However, this was not the case. These tests proved to be 100% accurate for both brands in this trial. The duplicates were indicating the same results as one another, and there were the same results across the brands, which correlated to the known spiked concentrations. So we were getting a reading of what we expected to see. Interpreting the quantitative results of the gold standard diagnostics provided some interesting interpretations. Although the known toxin concentrations for the low spike was 8 micrograms per liter, the results were interpreted as greater than 10 micrograms per liter due to no test line being present. So you weren't able to see any color present, which indicates, based on gold standard diagnostics instructions, that if there's no line present, it's above 10 micrograms per liter. So although the test produced accurately, the interpretation aspect requires more understanding, which leads us into the second experimental trial. In this trial, the focus was on the detection limits of each brand. The same methods were followed as trial 1. However, instead of natural water samples, deionized water was used and spiked with smaller incremental changes of concentrations to test for. This included 0, 1, 2, 4, 6, 8, and 10 micrograms per liter of microcystin LR. The results concluded that gold standard diagnostics can detect from 2 to 10 micrograms per liter, and 5 strands can detect from 1 to 10 micrograms per liter. It should be noted, though, that 5 strands did have a duplicate that did not accurately replicate the known positive at 2 micrograms per liter. One of the tests was able to detect that positive, and the tests were able to accurately detect twice at 1 microgram per liter, which is lower than this amount, which is why the range was considered lower. And then there is a color difference on this table for gold standard diagnostics because it, aside from providing a positive and negative result, it does give you an indication of that toxin concentration range, which I'll explain a little more on this next slide. When interpreting the quantitative results of gold standard diagnostics, it provides a further interpretation of that color gradient. It was not considered that 1 microgram per liter was positive because the test line was darker than the control, which according to gold standard diagnostics instructions, this indicates a negative test. The 2, 4, 6, and 8 microgram per liter concentrations were equal to and lighter than the control, which shows a change within that toxin level, and which is why they're indicated in that light green color of being within 1 to 10 micrograms per liter. And then the 10 microgram per liter, there was no line present, so it was marked down as being above 10 micrograms per liter, because according to gold standard diagnostics, this would indicate a test that's above that range that it can detect a specific toxin level for. So basically, this is interpreting that these tests can indicate up to 10 micrograms per liter accurately, because the tests were functioning, they were duplicating, the control was still there, the test was providing a result. But the color gradient does not necessarily indicate the specific toxin level accurately once above 8 micrograms per liter. And then lastly, we analyzed the accuracy of these test strips in field events during algal blooms. These samples were collected in the same manner as trial 1 with that triple rinse method to reduce potential contaminants. And as a precursor, the field sampling events did not have as many available resources due to how the resources for this project laid out, meaning there weren't enough resources to do all duplicates and utilize both brands for all sampling events, as blooms are unpredictable. So the first event was on the morning of August 21st, and we used this opportunity to test a popular beach location in Superior, which is Barker's Island Beach. And we only used gold standard diagnostics on at this time. And the results were split completely evenly between negative and positive, and that positive gave us a reading within 1 to 10 micrograms per liter. A water sample was sent to the Wisconsin State Laboratory of Hygiene located in Madison, Wisconsin. And when we got those results back, it indicated that this site had results of 1.1 micrograms per liter, meaning the negative test was accurate considering trial 2 indicates a detection limit of 2 to 10 micrograms per liter. So basically, this brand can't detect the 1.1 microgram per liter level because it won't indicate a positive. It'll read it as a negative. So when compared to the trial 2 results, which are shown at the bottom there, of what a 1.1 microgram liter result should look like, the positive tests during this field event are much lighter, indicating a higher toxin concentration, which was not the case as confirmed by that laboratory testing. In the afternoon, more sampling locations around this beach were collected. Both brands were utilized at this time because we wanted to continue and see what would happen. But there weren't enough 5 strands available to do a duplicate. Most of the tests were conclusive with one another, other than one of the gold standard diagnostic tests was inconclusive, and I have that picture on the bottom there with the black circles showing that there's none of that like pink color showing, so the test just was not working. And then there was also the difference in results between gold standard diagnostics and 5 strands with that middle Pickle Pond location, where one was reading as a negative and the other read as positive. But keep in mind that the brands do have different detection limits, as shown in that last trial, we discovered that, which may have caused these differences in results. And then there was another opportunity to collect an algal bloom event samples, and this was on August 26th. And this bloom occurred at an additional location just north of the first sampling date. And then Pickle Pond, which was sampled in the previous date as well, was also sampled. And all of these results were conclusive across the brands to one another. There is a color difference there just because gold standard diagnostic does give you that further information of the detection of the toxin present. That's the only reason that there's a light green there. They're both indicating a positive. However, there was no ability to do a 5-strand replicate on this date due to limited resources, and there was no lab comparison tested on this date to further conclude anything. So overall, both brands of the test strips proved to be comparable to one another. Both provide results in under an hour. Gold standard diagnostics takes roughly 35 minutes to complete one test, whereas 5 strands is a bit quicker with one test taking 15 minutes. 5 strands costs $25 per test, while gold standard diagnostics is $34 per test. And you do have to buy these ones in a bulk of either 5 or 20 pack. Whereas 5 strands you can buy individually. But with being a little more expensive, gold standard diagnostics can provide you a little more information about the toxin concentration of your sample, which 5 strands unfortunately cannot, aside from a positive or negative. Both brands were roughly 80% accurate in the field, with 5 strands being slightly more accurate, and this is a comparison of 81% to 83%, so they are very close to one another. Accuracy in these tests were focused on the reproducibility of a result. which both brands did well. In terms of application, gold standard diagnostics can provide more information to make an informed decision. However, the color gradient is not necessarily straightforward to interpret. It's really up to the person who's looking at the test and looking at the color, and it can vary from test to test. And this can be difficult to comprehend. 5 strands is a little more accessible for a range of users with different backgrounds. And it's also available on Amazon.com rather than through like a laboratory provider like Gold Standard Diagnostics is. And it also has fewer procedural steps overall. However, it does only provide a negative or positive result, which does not indicate how high or low the toxin concentration is. Yeah, thank you.
All right, great. Thanks a lot, Janae, for that. We do have a couple of questions coming in here. Let me pull them up. Did you use a plate reader for the GSD strips?
No, it was all with visual interpretation by me.
Okay. Do these tests expire?
I believe they do have an expiration date. I don't know what it would be off the top of my head.
Okay, but at least like the ones you got, I guess you were able to use them for that year anyway.
Yep. Yeah.
And then we've got a couple questions about the concentrations. Are there any other tests that may be more successful at measuring concentrations above 8? Why are the results more uncertain above this threshold?
Like the fact that above 8 isn't necessarily showing that it's like under 10 micrograms per liter.
Yeah, I think they're talking also because there's another question about the ranges. So like,
Okay.
I guess the question is kind of like, why are we getting these ranges or these instead of like one value? Is that just a limitation of the test or?
I think just from the trial I did, it seems to be a limitation of the test itself. We want to do more research moving forward here, especially with like live algal samples, because that's where we really started to see differences in what the tests were showing us. In a
Yeah.
controlled scenario, it was providing really great accurate results with those ranges that we were able to see the specific detection limits. So I think that's all I can really say for now on that.
Yeah, maybe some more trials will help kind of sort that out. Do you know if any local public health jurisdictions are using these to inform lake management decisions?
I do not know off the top of my head. I think this is relatively new technology that's being looked into.
Yeah. All right. That is all I have for the moment. So we'll wait a second, see if anything else pops up. But if not, I'm going to share my screen again. Nope. Here's another question. I missed your cell lysis step. Can this be done in the field?
Yeah, all of the lysis steps are done with what's provided within each of the test strip kits. So 5 strands, it does the lysis for you through a chemical reaction that occurs with the provided sampling container that you put your water sample into. And then Gold Standard Diagnostics, you physically do the lysis with shaking by adding reagent paper to a vial, and there's like a lot of different steps to make sure that lysis is occurring.
Okay, great. And then somebody did put in the chat that they know of a health department using those strips in Lake County, Illinois. So appears they're being used somewhere. Let's see. Do you know how long these tests have been available? Like, are we expecting maybe the costs will come down at some point?
I honestly, I have no idea. I was first introduced to them over the summer, so.
No problem. And Okay, somebody is explaining some details about failure to detect and saying that studies in Ontario using these have found that about a 10% rate of false negatives occur, and it'd be great to have more studies in other areas with other cyanotaxa as well. So that was mostly just a comment. And then, yeah, that's a good question. So Mary is asking, are the findings from these tests accepted by local municipalities to support a beach reopening? And then we can open that up to, if you're not sure, we can open that up to the larger group as well. Anybody know if that's enough to reopen a beach? And it looks like Kate's answering some of these in the chat as well. So, Gloria says that she's been using the GSD test for about 6 years now, and the price has increased slightly over that time. So maybe not too much competition for those yet. All right. Right. Well, thanks again, Janae, and to all of our speakers, to Sam, Peter, Laura, and Jeremy for presenting this afternoon, and for all of our speakers all day today. We really appreciate you attending this 5th annual Harmful Algal Bloom Symposium. We hope to see you at a future one of our bi-monthly webinar series or next year's event. And I believe, but maybe Anne can confirm this, that there'll be an email going out once the recording is available in case you want to share this with any of your colleagues. So Anne or anyone else, any final comments to share?
Yeah, absolutely. And check that website, northcentralwater.org/HABs. That can be the location that you should go for the recording as well as the presentation slides as they're available. Once we have everything compiled, we will send out an email, but you can check that on a periodic basis for those updates.
Awesome. Great. So yeah, visit their website for the details. And lots of applause coming in. So, all right. Yes, thank you, everyone. It was great to see everyone, and have a good rest of your day.